Hey everyone, I'm trying something new for the stream today. I have Zoe here live with me chatting, and he's a subscriber. I'm going to attempt teaching OCaml uh, on stream today. Right, so I before starting, I gave the motivating example to Zoe to code it up in their language of choice. Happens to be Java, and the program looks like this. Let me open it up. It's this, right? So what is it going to do? A program where the user continuously enters numbers until they decide to quit. The program will display the sum upon completion. Right. So it's got minimal error handling stuff, where if you do not enter a number, it's going to report that. Hey Sridhar, welcome to the stream. Right, so let's run this program and see. Let me call this OCaml. Right. Oh, sorry. Oops, I missed. Okay, so I'm gonna just do Java some stream for Java. You can see that it's asking for user input. Let's say we enter 4, and then let's say A, B, B, and then 2, and then Q for quit. Right, it returns the sum as 6, which is fair because it only added up the numbers that were inputs that were numbers. We're going to translate this into OCaml. And let's see how that goes. And along the way, I will shoot off tangents to explain everything that Zoe is going to ask or the chat is going to ask. Okay, let's start with the conversion of this particular line. We initialize a variable sum to 0. How do we do that in OCaml? I'm going to start with the REPL of OCaml. There's a good implementation of a REPL in OCaml called utop. I launch it up, and then I get treated with this typical read eval print loop interface where I can do stuff like 1 plus 1 plus 40, and then semicolon, semicolon to actually trigger evaluation. We'll get to that in a bit. But yeah, so this is going to output 42, right? Zoe, just please feel free to ask questions at any time, right?
Okay.
Yeah. So
Quick question. Why are you using the REPL as opposed to like an IDE? Is it just so you don't have to deal with any overhead?
No, REPL is just faster to experiment with things, right? This is very nice. I mean, I wouldn't have to write something in the file and then compile or run it in some way to get the feedback, right? REPLs are very fast, where you get the output immediately after you are done with that line, right? This is only for
Okay, so
experimentation. We'll eventually move to a file. Right, so what do you
okay,
see
so it's good
here?
for like demonstration.
Sorry?
It's better for like quick demonstration purposes.
Yes, yes. Not just demonstration purposes, it's also for experimenting. Like you can see at the bottom of this particular REPL, you get some autocomplete stuff, right? You can do something like list and then do a dot. Then you get this kind of a completion. Of course, you get this on an IDE, but it's not line based. It's whole file based. Sometimes you just want a simple line evaluation where you go reach out for a REPL, right? So this is pretty clear. The line that what I made it read was that 1 plus 1 plus 40, and it returned that result to be 42. But there's a little bit more to unpack here. You can see that it also has automatically recognized that it's an integer. And on this side, we have this hyphen. So the way you read this is a name colon the type equals a value, right? There is no name, that's why it's a hyphen. And the type is going to be an int because OCaml has a really strong type system. It uses something called HM system, Hindley-Milner system, where it tries without you having to tell it what the type is, it will automatically figure it out, right? So it's figured out that it's an int, and the value we got was after evaluation 42. Is that clear?
Mm-hmm. Yeah.
Now let's do the sum equal to 0 part, which is right here, right? Let sum equals 0. And to actually trigger evaluation, I have to do double semicolons. Now you'll see the difference where you have something more on the left-hand side of the colon, where it says val sum of type int is 0. So what do you call this, Zoe? What is sum?
It's the variable name.
Okay, variable name. That's actually a nice way to put it. What I want to make clear is that sum isn't a variable, just like it is in case of Java. Here, sum is a variable, right? And the value of sum varies every time the program executes this line, right? But it's not a variable in the same sense in OCaml. In OCaml, it's called a binding. So we rather say that sum is a name that is bound to value 0. Because you cannot change the value of it. Let's see what happens when you do. Sum equals 5. Can you take a guess?
It'll throw an error because you said they're basically immutable, is what it sounds like.
Yeah. Anybody in the chat that can take a guess? I know there is at least one person who already knows OCaml. Okay. Seems to be inactive. That's fine. So yeah, you said it's going to throw an error. Look what happens. Can you guess what happened?
Boolean equals false. So it looks like from what I'm seeing, it created a new, so it's a hyphen, which is the default name for a binding when you don't supply it.
Yeah.
Of type Boolean, and it's giving you, my question is, what triggered that? Like, where did that come from? I don't know. Maybe every time you assign a value, it returns. You know how kind of like in Java, when you add an element to an array list, the add method actually returns true or false? Maybe it's something like that.
Add method returns true or false. Is that true?
In Java, yeah, the array list, when you do like array list dot add, it returns true or false,
Oh, we can
letting you
check
know
that
whether
out.
the element was added.
Do I have JShell? I do have JShell. So you're saying what list.add?
Yeah, it should be. Yeah, Boolean.
Oh, maybe like array list.add. What is the? Do you know the syntax? Is
Or let
that
me go to the. You could just add maybe on the JShell. I'm not sure how to do it. Let me just pull up the Java API real quick.
Okay. So I have to first clear it. Array list numbers equals list dot of. I don't know if I can do it this way.
Wait a minute, where is? Yeah, let me send you the website to the API, and if you look up the add method, you'll see that the return type is a Boolean.
Oh, so if I do nums.add of 0, wait, what does it say? Oh, it does return a Boolean, but so this problem was yeah, I have to do something like yeah, so I did not give the type annotations. That's what it's complaining about, but I can see that it returns a Boolean. So this indicates whether it was able to add it to the list or not, I guess.
Yeah, nobody really uses it though. I haven't like I was kind of surprised to learn that it even does that.
Oh, interesting. Okay,
Maybe people.
yeah,
Yeah.
I thought it was a void return.
Yeah, you
Uh,
would that me too.
cool. Okay. Yeah, but look at the next thing that I did, where it returned a true.
Okay, because it was initially zero, so you're rebinding. True. So maybe it looks like maybe it's actually like an equality operator. You know how like you can do double equals in Java to see if something is, oh, is that what it is? Is it like
Yep.
equivalent to double equals?
That's exactly what it is, right? There's also double equals. We'll probably understand what that is, but you need to remember that outside of the context of a let expression, right? So let sum equal zero. In that context, equals is binding. Okay, when outside of it, it's actually just your normal comparison operator, as
Mm.
Sridhar in the chat confirms it, right? So it's a comparison operator. All right. So how do I? Yeah, like my point was that you cannot really rebind something. Like when sum is bound to zero, it's going to stay that way for the rest of the program until it goes out of scope or whatever, right? Uh, okay. What is the next thing? Let's see, how do we read a number from the command line? Okay. We have we have multiple methods to read from standard in. So I think there you can already see that there is a read int, there is a read float, there's read line. Which one do you want to try?
Um, let's do readint.
Okay, read int. Um, if I just execute, I mean, if I just evaluate the function, can you take a guess of what happens?
If you just run this,
Yeah, yeah.
it might wait for input.
Interesting. But look what happens. You can try to read this. Let me see if there's another function. There's, I think, yeah. So, can you read this? Do you have any
Yes.
thoughts about this?
Uh, okay, so it looks like again it's defaulting. What's kind of thrown? Okay, so it looks like after the colon, I know you said that that's followed by data type. I'm seeing
Mm-hmm.
two right here.
Mm-hmm.
Unit, arrow, int. Int makes sense. I don't know what a unit is, but I'm gonna assume it's a type of data.
Mm-hmm.
Equals, and then bracket fun. So in Java, I know the angle brackets mean like data types, or they kind of specify generics.
Mm-hmm. Mm-hmm.
Actually, I'm not
There
too
is
sure.
no relation between Java or like in between Java and OCaml. It just happens to be that
Oh,
we end up with the characters.
maybe fun is
Yeah.
maybe fun is short for function.
Yes. Absolutely. And slight correction. I didn't mean that it's the data type. I meant that it's the type. I don't know if that actually makes a difference, but yeah, it might make a semantic difference in your head. But yeah, you got it right. So almost right. Again, we do not have a name, so it's hyphen. The type is actually this unit arrow int, and then what's going to be here? It's always the value, right? When you do equals on the right hand side of equals, we always have a value. For example, here was true, false, 0, 42, right? But in case of functions, the value doesn't really exist, or more that the value is a function, right? So the type of this
Yeah.
function is going to take unit and then produce an int. That's how you read it. Okay? And what is unit? Is actually type is a type that has a single value, right? For example, Boolean is a type that has how many values?
2.
Right. Unit is a type that has a single value. And that value is this. So Boolean, right? If I just do true, look what happened. It says Boolean true. And then there is false, and Boolean value is false, right? And then unit is this. Look at this. Unit is this. There is no other way to construct a value of this type. This is the only possible way because that's the only value possible in that type, right? What does it indicate? It indicates nothing, right? Because there's no value to, like, it's just an empty pair of parentheses. Have you worked with tuples?
No.
Okay. Tuples are like an arbitrary collection of items, right? List, when you talk about list, everything is homogeneous, right? You have a list of integers. You know that everything inside the list is an integer. But a tuple is a little bit different in that sense, where every type can be different. I can very easily create a tuple of a string and a number. So I can say Zo and the number 4. This is a tuple. Okay, you can see that the type of it is a string times integer, right? And the value is exactly what I typed, right? I could do something like Zo and then 1 plus 1. It's just going to evaluate it, and then the value is going to be the result of the evaluation, of course. But you can see the type is string times integer. So unit is like a tuple which has no value. Make sense? I can just do something.
Okay, and is
like,
it specific? Is it specifically used to define functions, like the data type of functions?
unit?
Yeah.
You could say that. Yeah, so unit is to indicate nothing. So read int, if you go back, right, read int, it takes nothing and gives you back an integer. And there are other functions like print a new line, right? It doesn't take anything and it doesn't produce anything, right? I mean, as a value, it doesn't produce any value. What it does produce is a side effect. How familiar are you with side effects?
Not very.
Okay.
Okay, so I'll tell you what like my understanding of it is. I've heard it in the context that when you pass an argument to a method, sometimes that method might change the value of the argument you're passing. So if you pass an array list, you might not get, or if you pass an array, you might not get the same values inside that array back.
Yeah, that's one side effect. Oh, sorry, I missed one question. Orochimaru is asking, it's camel. Yeah, it is camel. It is OCaml, to be more precise. Yeah, so that's an example of a side effect where a function is taking an argument, list, let's say, and then it's adding a bunch of elements into that list. And when the function is over, whoever passed the list gets to see that change, right? Function did something to the argument, and then once the function is complete, whoever called that function is also able to see that change. That is an example of a side effect. But side effect is anything that changes the world around in a very naive way. That's how I can put it, right? Printing to the screen is a side effect, right? And reading, yeah. I mean, I don't want to get too much into what that is, but idea of a side effect is the fact that something got executed, you can trace it back, or there is proof that it ran, it did something, right? It's about doing something. It's a side effect. Printing to a
So it
screen
leaves
is a
like
side
some
effect.
sort of imprint in some way.
Yeah, in some way. It could be writing to a file, it could be writing to a database. All of those things are side effects, right? Even changing the, you have a variable, right? You have a variable sum, and then you're doing this plus equals operator, and then you're changing the value of sum. Even that is a side effect, because what is happening is you're changing the value that's stored in memory. You see what I mean? That's a side effect. It's not producing any value. It's actually doing doing a side effect. Does that give you at least a brief understanding of what a side effect is?
Yeah, it makes some sort of change. Quickly there, you said you had mentioned the word naive. What do you mean by that?
Uh, it's it's not the complete definition of what a side effect is. I just wanted to simplify the explanation of it. That's what I meant by naive.
Okay. So any change, like there's no, it doesn't have to meet some sort of criteria before it gets categorized as a side effect. Just any change of any kind would be considered a side effect.
In a way, yes. Again, naively. I mean, we can argue about, so even if you're writing a pure function, which is, yeah, that's also changing certain things in a way, but for now it's okay. Like it's I think enough for you to be able to differentiate what's a side effect and what isn't. You As we go, right, we can have like a simple exercise of what is a side effect, whether this is a side effect or not. Okay, so uh, how do you produce a unit? Now we need to supply unit to this function, right? And this is saying that you give me a unit, meaning you give me nothing, I'll give you back an integer. That's what it's saying. So let's give it unit. How do we construct a unit? We just do this, right? This is how we construct a unit. So let's actually pass it to read in and see what happens. Oh, you see what's happening? It's actually waiting for input. Let's say I want 50. There you go. It produced an int. You see, I gave it nothing, the unit value, and then it actually waited for user input. And then once I entered the number, it produced the value of integer, right? If I would have done like this, oh, what do you see here? It's an exception. OCaml has exceptions, but the generally, we do not use exceptions. We use there is a different way of there's a different way of handling failures in the language. We'll go through them in a bit, but yeah. So read int. If you do not give it a string that is not convertible to an integer, it's going to throw an exception, right? We wanted, okay, so this thing is pretty much done for us. We're parsing, we didn't need to do it later, but we'll see. What else we saw how to read? Oh, there's just one more example. There's read line. You see this? The notation is different now. You give it unit, but it gives you a string. If I do read line and then I give it unit and then I say zo, and it gave me back a string. But if I gave it like 50, it'll give me back a string 50, not an int 50, right? Okay, so imperatively, what we are seeing right now on screen is an imperative solution to the problem, where you initialize a variable, and then you start a loop, and inside the loop you have you start by asking for user input, and then you immediately check whether that input is equal to q. If it is, then you just break out of the loop, right? If it is not q, or any command that is not indicating the program to quit, you try to parse the input to an integer and then add it to sum. If there is an error while parsing it to an integer, you just print that it's not a number. And then at the end, how do you go to the end? There's only one way to go to the end. You could just be infinitely going in this loop until the user, if the user never enters a queue, right? And then you print the value to the screen. Okay, so let's also see printing values to the screen. There is print int, and you can see that it's like flipped around from read int. This one takes an integer and then it gives you nothing. But what it does do is print it to the screen. Print int 50. You can see like it printed 50. This is not the name, by the way. It's just that it printed here and then it immediately started with the binding, right? Which happens to be nothing in this case. I can also do, I think, something like let x equals print int of 50. Oh, look at that. So x, I just gave x a name. I'm sorry, I just gave a name to unit, which is x. Okay. All right, so how do we go about this? Imperatively, we know that we want a loop. We want a variable that keeps accumulating values. But there's a different approach to this, which is more like which is a declarative one. Okay, there's the idea of sequences in OCaml, you know, and I can access.
Quick question. What's the difference between, you had mentioned imperative and declarative. What's the difference between the two?
Imperative, you can see that you are also dealing with the how parts of your problem. You're not saying what do you want, right? What are you doing? Primarily, you're summing integers up. But along with summing integers, you're also dealing with the how, right? How are you doing it? By looping, by having this initial variable and then accumulating values in that variable. Yes, a little more low level than it needs to be. I mean, sometimes we do need it, but that's the difference between imperative and declarative. You are having to deal with the how parts of your solution. And once we'll see declarative a declarative solution, we should be able to talk more about the differences, and you should be able to get a better understanding at that point, right? In declarative, the idea is you are more focused on the what part of things. Okay.
Okay.
Yeah, back to sequences. So there is this thing, seek, and in this one I have something called ints. Okay. Look at the type. It says it takes an integer and then it gives you back a sequence of integers. The way you read this is a little bit it's inverted in a way that it's a sequence of integers, or more like if you just want to go the left to right, you can just say int sequence. Before that, we have I think we should talk about lists. Lists are very fundamental to the language, and that's true for any functional programming language because lists are very nice to work with when you are in an immutable world. Okay, so let's see how we construct a list of things. So I can do list of 0, and then it's a semicolon. It's not a comma, as it's usually, to separate the items in a list, 0, 1, maybe 10, right? You can see that it's an int list. The type is an int list, and the value is a list containing the 2 numbers, right? I can do similar stuff for a character. I can just do this, and there you go. I get a char list. And then I can basically I can construct any a list of any type. And this is where you can start relating with Java generics, right? When you specify a list in Java, you have that angle bracket parameter, right? Type parameter that we call it, where you specify what's the type of elements that are going to be in this list, right? It's the same way, just the notation is different. So this char list is analogous to writing list of character in Java.
Okay.
Right. Okay, so how do we go about this? So we talked about lists, and then let's also see seek.ins. Yeah, it takes an integer and then it gives you a sequence. Let's actually give it a number, right? Let's do seek.ins and let's give it 5. Okay, so now we have a sequence of integers, right? Then we have some functions that can manipulate this sequence. So there is something called iter. Okay, this might be a little too much at this point, but can you see what's happening here?
Yeah. Sequence.iter. Yeah, I see the output. As far as what's happening, it looks like iter A goes to unit. I don't. If I had to guess, I mean, when I think iter, I think looping.
Yep.
So I think it's looping through. But the thing is, you specified the list as a int, but it's pulling up A, so I'm not sure why.
No, because I have not given it anything. If I,
Oh,
you see what I mean? Like I have not given it anything. This is a generic function. It can take any sequence. It doesn't care what sequence it is, right? Oh yeah, I think it's a good point to bring out this tick A. That's how you specify generics. Tick A is like the T parameter. If you see in Java documentation, right, you would have list T like this, right? This translates to tick A list in OCaml. And in our case, it's not really a list, it's a sequence, so it's seek.t. Okay? What this indicates is seek.iter, as the second argument, takes a sequence of A's, and these A's can be anything. They can be ints, your custom type, it can be booleans, whatever. Right? But seek.ins is a specific value which takes it's rather a function that takes an integer and it gives you a sequence of ints, right? So you can pass that to this, right? You can when a function says I can take tick a seek.t, you can pass any sequence to it. It just needs to be a sequence. That's it, right? You can pass it a sequence of strings, a sequence of booleans, a sequence of characters, whatever. Okay,
Okay.
tick A is like the generic, or it could be any type. So, but the thing is like every is homogeneous in the sense tick A seek T means like every element in that sequence is of type tick A. Okay. Yeah. So the first part is actually a function. So we're in the land of functional programming, and one of the first expectations is that functions are treated as values, just like values, right? So you can pass them around as values, right? You can pass a function to another function as an argument, or you can return a function from another function, and you can also bind a name to the function, right? Let's actually go. Let's define a simplistic function, right? We'll also look at the anatomy of a function in OCaml along the way. So let's define. You tell me, like, what function do we want to learn? A simplistic function we want to design.
A simple function, maybe swap two numbers in an array.
Really bad example
Yeah.
because swap is side effecting. What are you doing in a swap? You're doing side effects. So yeah, I don't think that
Oh
was a
yeah, it's
good
not very
idea.
simple. I think I'll leave that to you then.
All right, so let's
Well,
do a mathematical function add. Okay. This is how we define functions in OCaml. Let add x y equals x plus y. Hey, there we go. You see this? Add. Now this is the name part. This is what is going to be bound to the value. Type is going to be int to int to int equals a function. Of course, the value is a function, right? It doesn't have like a normal representation of a usual normal representation of a value. That's why it's like a angle bracket function. Whenever a value is a function, on the right hand side of equals, you're going to get fun. Okay, so what you notice that there's so much less that's happening to add. If you were to do this in a mainstream language, you'd have a lot more characters, right? But this is working just fine. Even calling it is lightweight. Syntactically, I mean. Add 4 and 5. There you go. We got a value, right? So is this clear to you, like what's happening?
Yeah, it's like you're almost treating it as if it's a variable, the add, and then x and y are the arguments, and then on the right-hand side of the equal sign, that's where the actual function is occurring. That's like the method body. But
Yes. Perfect.
yeah, it's different than
Yeah.
what I'm. And okay, so then like normally in Java, instead of the x and y being separate from add, you'd have a parent. They would be enclosed inside of a parentheses specified data type. So I'm seeing that they just kind of got rid of some of the unnecessary stuff. How does it know it's an int?
Great question. Great question. Because this function, this plus that you see, is actually a function. Okay. How do I know that? Because you can do stuff like this. There is this. If you enclose an operator in a parentheses, it turns into a function. Right? Look at this. There is already a function called add, but I just used it differently. Now, this function, let's actually do something more. Do something more with this. What do we want to do? 2 times. Let's say. I'll just call it f. Okay, and it takes x and y, and it does 2 star x plus y. Just a simple mathematical expression, right? But it's still able to figure out that x is an integer, y is an integer, and it produces an integer, right? How is it able to understand this? calling back to the Hindley-Milner type system, it knows about star, it knows about plus. Okay, when you do this, what is this saying to us? Plus is a function that takes an int, another int, and produces an int, right? This means that the operators that I pass to it have to be integers. I mean, sorry, arguments that I pass to it have to be integers, right? So I can do stuff like 4 and 5. Look what happens if I just do a character and this. It says, hey, this expression has type char, but an expression was expected of type int. Yes, Sridhar, thank you for pointing that out. Yeah, that's called type inference. Like the compiler is going to infer the types for you, and it's going to work like 98.6% of the time. That's a random number, where you do not have to specify the types at all, right? You just do your thing, and the type system is smart enough to figure out what's going to be the return type of this function and what type of argument is going to take. Right? It all is figured out based on usage. Okay? So is it clear that plus takes 2 integers and then produces an integer?
Yeah.
And then star also does the same thing, right? So the type system goes here and then it does the star. Okay, star, for this to be type checked, I mean, for the type checking to pass for this, the left side has to be integer and the right side also has to be integer, right? And then plus takes now how precedence is gonna go like this, right? This is going to get evaluated. The left side, now, is this an integer? Yes, because what does star say? Star takes 2 integers and produces an integer. Okay, so the selected region is producing an integer, okay? And right side has to be an integer. We don't know what it is, but it's only going to be a valid binding if y is an integer. That's how it's able to figure out that, for star to work, x has to be integer, and for plus to work, y has to be integer. Why? Because the plus and star are already known by the system, right? Mm-hmm. That's how it's able to figure out automatically. And what is f? F, okay, it takes now x and y, and from the usage of star and plus and whatever, it's able to figure out that x is an integer, y is an integer. Of course, this int, and what is it going to produce? Of course, it has enough information that, okay, when you do a star, it produces an int, and then that int is actually supplied to plus, and plus also produces an int. At the end, you will have an int, right? That's how it's able to understand that, deduce the signature of f. Is that clear?
I got a question. So if you were to do let f x y z, would it be 4 ints in the output with the arrows?
Yeah, what do you want the body to be?
Anything, just as long as it includes all 3 arguments.
I could just do x plus y star z. Anything is fine.
Yeah.
Yes. So that's a good question. I think you've probably understood the pattern here. The last thing is the return value, and everything that comes before the last arrow are the arguments.
Okay. So
it's not the
backwards.
Sorry?
No, I was just in my head. It's a little backwards. You're saying the last thing is the return type of the method, and the 3 preceding ints are the arguments.
Correct. Yeah. So it's the other way around, right? In Java, you've got the return type first, and then you've got the arguments. Right? Mm-hmm. And whatever I said, again, it's not entirely correct, but that's enough information for you to make sense of what's happening, right? You've got the return type at the end. Okay, so let's go back to our add function, right? It takes an integer And then we also saw it working. So it would be like 40 and then 1. We get the return value, right? And of course, we can assign it to, not assign, we can bind it to a name like this, 41. Okay. Question for you. What do you think happens if I just do this?
There's a bit of a delay, so give me a second on the screen
Sure.
to see. Okay, you're asking about add 40?
Yep. So how
What
many
do I think's gonna
arguments does
happen?
how many arguments does add have?
2.
Yeah. So I'm only supplying one argument to it. What do you think is gonna happen?
I think it would throw an error.
Okay. But this is what happens. You can excuse me. You can refer to what add was and what happened.
You just created a new function, it looks like.
Absolutely. It's a new function where the first argument is actually burned in to be 40. You see like how it ate up one of the arguments, argument types. So it was int, and then it became like int and int. You see like it ate up one of the types. One of the ints.
Uh-huh.
Yeah, so that's what's happening. So I can do now. It's a value, right? Add 40 is a function, and the function is a value. And of course, I can bind a name to it. So I can do let add 40 equals add 40. Looks weird, but it should be possible for me to do that, right? Now, add 40 is a function that takes an int and produces an int. Okay, I can do this. Yep. Add 40. What do you think is gonna happen?
Hold on, give me a second to see it pop up. Okay, add 41, semicolon, semicolon. So let's see, you assigned add 40 to the value of whatever add 40 is. So what does add 40 equal? The result of add 40, and now you're passing a 1.
Yeah, you
I
can
think
see. You can see here that, right? Add 40 is a name that is bound to a value of type int to int, which is a function. Right? It takes an integer and it gives you an integer. And yeah, go ahead and make a guess.
Okay, so once you pass 1 to add 40, what's it gonna do? Man, I have no idea. Does it pass it to the add 40 method and then that passes it to the original add 41 method? Well, if I had to guess, I would say man, I really have no idea. I don't know. I'm a bit lost, to be honest. I got a bit lost on this part.
Yeah, but you can still make a guess. Could be wrong. But logically, what should happen?
You're passing it it should return a number.
Yeah,
It should return an int.
yeah, of course it does return an integer. What happened was 41. It gave us a 41, which is fair, right? So let's look at what happened. So we have add here, which takes an int, another int, produces an int, right? And then what we did was we burned in like one of the arguments by doing this. When I did, when I did this, right? When I did add 40, it burned in the value for the first argument to be 40, right? And then it actually gave a function that takes another integer and then it returns an integer. Okay? And that's what the
So
yeah.
Okay, so these are kind of like is this some sort of like Russian nesting doll kind of idea going on? Like there's a connection between all these methods. Like does add 40 call the previous add 40 and the previous add and
No, no,
that
no,
calls
no,
the other
no,
add
no.
40 one?
That's not how you look at it. You look at add 40 as a new function that is capable of taking one integer and giving you back another integer. That's
Capable
it.
of
Like
taking one and okay.
that's what it's doing, right? It's pretty clear from this
Mhm.
line. Uh, do not worry about how things are happening underneath. It's not important at this point. What you just need to see is that God, we had add, which took which took one integer and another integer and gave an integer. That's clear. When you supply one argument to a function, you need to understand that in OCaml that actually is like burning that value into that first argument, right? And look at what happened when I did this. It gave me back an integer. It gave me back a type that is capable of taking one integer and then giving back another, right? This line is just binding a name to whatever this is, right? I just did add 40, but then I bound it to add 40. I could have bound it to something else. Maybe it's less confusing if I do this. I'll just say G equals add 40. You see what happened? Like add 40, burn the value to the first argument, and then we get back a new function, right? We get a new
Burn the
function.
value to the first one.
Yeah, so it's like you take this and then you put it to the first argument of the add, which is here. So this one is going. It's like when you get a value back, it's like you are already having 40 in place, and then you take another integer, and then you do whatever the body of the function says, which is doing x plus y. Does it make sense?
Yeah, kind of. Yeah, yeah. I get the idea that like there exists a 40 kind of behind the scenes because
Yeah, because that
you
was
did
done
that
in this
equal sign.
case. Yes, that was done here, and I think we also have this f, which is taking like I don't know what it's doing. Maybe we can go up and see. Yeah, so it's doing x plus y star z, right? So if I give it like three values, 1, 2, and 3, it's going to give me 7 because 1 plus 2 times 3 is 6 plus 1, 7, right? And look what
Hmm.
happens. F, you already have the signature of it. If I burn 1 here, I actually get a function back, right? It was burned. It was burned in here, and then I get a function back. I can just do f1 and 2. Oh, I get another function back, but it's like it has eaten up another argument. Now, when I give it the last argument, it's going to produce a value, right? F1, 2, and maybe 10 this time is 21. So earlier, I just did the part where I bound this specific function to a name. That's it, which was add 40, and G in another case. Does it make sense?
Yeah, yeah. It does. It definitely does. From like a general overview.
Hmm.
Okay, so the thing that's kind of like throwing me off right now is there's about like a 7 second delay from what you say and what I see on screen. So like you say something and then I have to keep it in memory and then I see you act it on. So that's I think that's what also is causing a bit of
Oh
it's
wait.
hard for me to kind of like be juggling all these
Sorry. Let
things
me
that I
go, man. This was bad. Just watch Discord.
okay.
I've shared my screen. You can close the stream entirely.
All right. Yeah,
Just
I'll
keep
just do
watching
that.
the stream. Oh man, I didn't realize I was doing this. Oh god.
No, no,
Uh,
you're good. No worries.
all right.
Okay,
So
can you just like type something on screen real quick? I just want to see what the delay is.
hello.
Okay, you're yeah, much better.
All right. Oh man,
Okay, yeah.
I didn't realize you were in that turmoil all this while. Sorry for that.
No,
But
it's
yeah,
good. No.
so this is OCaml for Khan. Welcome to the stream, by the way. So we're discussing partial function application at the moment. We were at the part. So we have f. Let me just see what f was. Let f. Right. We had this, and I was saying like when you do f1, it's going to burn this 1 into the first argument. And when you do f1, 3, it's going to burn 3 into the second argument. It's going to give you another function. And because functions are first class, I can just bind it to a name. I can just bind it, say, like q equals f13, right? And now q is a function that takes an integer. And when I give it an integer, it produces an integer, right? Like I give like 2. There we go. I got 7 again because 1 plus 3 times 2 is 1 plus 6, and then 1 plus 6 is 7. And that's how the evaluation goes, right? Does this make sense now?
Yeah, so quick question. So, when you do let q equals f13, if you did that, but you did something like maybe uh, plus b, would the output be int arrow int?
Nope, you cannot do
Would it
that.
be th
You couldn't do that. See what happens. Plus 0. Let's do this. See what happens? F13, you see like F13, what is the type of this? F13 is a function, like you read it from the right, is a function that takes an integer and produces an integer. There is no meaning of adding a function to a number. What does it mean? So it's not going to compile.
Okay. Yeah, I see that. So there's no meaning of adding a function to a number. So F13 evaluates to just one number. That makes sense, right? Because it returns one single number. It takes in two arguments, but it'll spit out one number. How how come it doesn't so like F13 should evaluate to one single number,
No,
and
no, no, no,
then
no, no.
once it
F1,
evaluates.
no, no, no. F takes 3 arguments. F13 evaluates to a function that is still waiting for another number before the evaluation happens.
Oh, F13 evaluates to another function.
Look at this. Look at this. It's clearly this line, right? It's evaluating to a function that is waiting for another integer. You can,
Okay.
yeah, you can take you can simplify it, right? Add is int. You give add 1, so now it's waiting for another number, right? And then when you give it
Oh,
another
to add
number, that's when it's going to do the production, right? Even here it's producing, and what it's producing here is actually a function. When you supply 1 to it, it's producing a function, right? And then when you have this function that goes from int to int, you've supplied an int and it's going to produce an int. You see how it's working? Yeah, so this
Hold on.
is
When you pass, okay, so add one, it won't actually return a value. It'll just evaluate to a function.
the return value itself is a function. That's how you see it.
Okay. Return value itself is a function.
Isn't it a function? It's pretty clear. It should be pretty clear, right? Add is a function. Okay, takes an int, another int, gives an int. Add 1 is also a function because that's clearly indicated by the right side of this, right? It's a function. But it just takes one integer because 1 is already burned in here. So I'll do this exercise again just to make it clear. You can assign a name to it. Add 1. I'll just say add 1 equals add 1. It's literally this way, right? Now, what is this? Add 1 is a function that takes an int and produces an int. So if you give it an integer, it's going to produce an integer. What integer does it produce? That depends on the definition of the function, right? And in our case, it's true to true to its name. So if I give it 5, it's going to produce 6. It's similar to readInt, right? I mean, of course, because that's also a function. You give it unit. This is how you give the unit, supply the unit, and it's going to produce an integer. How is it going to produce an integer? By asking the user for input and then converting the user input to an integer. That's how it's going to produce it, right? That is the body of the function of readInt, right? And then I enter 4, and then there I have it. And then if I enter something that cannot be converted, it's going to throw an exception. Okay.
Mm-hmm.
Now, earlier, yes, you had a question?
No.
Okay. Earlier I said that exceptions are kind of frowned upon in the language. There are other ways to deal with failures. Okay. Now I'm going to express my frustration with exceptions or functions that kind of lie. Okay. This readInt, what is it saying? It's saying that you give me a unit and I'll give you an integer, right?
Mm-hmm.
But it's not always true. It fails in certain cases, where if the user enters an unconvertible number, it's not going to give me an integer, but it's not really saying it in the signature, right? It's lying to you in a way, right? It's lying to the user of the function. Hey, you give me a unit, I'll give you an integer, but sometimes I throw an exception. Sometimes I throw an exception is not clear from the signature. Agree?
Mm-hmm.
And
Yeah.
this kind of thing happens in Java all the time, right? Where return type is an object. Okay? Let's say you're reading a user from the database, you give it an ID, and the function and the method is saying that it's going to give you a user object back, right? The signature will look something like this. Public user, get user, and then it's going to take some ID, and then blah, 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 right?
Mm-hmm.
Maybe it also throws some kind of an exception, but the signature itself doesn't really say. So, okay, let's say it does throw an exception. It throws user not available. Let's say, okay. What can happen here is that you can return a null from this function without throwing an exception, right?
You go return a null without throwing an
You can just do this, right?
Uh-huh.
And this compiles. It type checks and it compiles and you can run the program. Correct?
Yeah.
But
yeah.
let's say you do zo equals get user. I mean, don't worry about the syntax. Get user, and then let's say ID is like this. Okay.
Mm-hmm.
And then I do something like system.out.println zo.name. Assume that user is a class that has a name property. Okay?
Okay.
Now, can you see the problem in this?
Yeah, I'm expecting to get a user back.
Mm-hmm.
But it's null.
Yeah, it could be null. In some cases, it could be null, right? Even though, so if this is a checked exception, then this is not going to compile, saying that, oh, this is a checked exception, you have to do a try catch. Okay? In Java, it's going to say that. But even though there can be, like, you can write your code in a way where you are returning a null without throwing an exception. It's possible, and the program compiles, but it's going to blow up at runtime because you have a null here, and then you do a null.name, you're going to get hit with the null pointer exception. Agree? Yeah, and every time, if you're using an ID, it might be fair, but if you're not, this throws, you don't really know. If you're just looking at the function signature, you're going to see, oh, I'll give it an ID. It's going to give me a user. Okay, right. I'm going to use it as a user. But the thing is, Java has nulls. Oh man, that means this could be null at point. And if you do not handle this with experience, you get that sense. Okay, things can be null. You have to check for them, and then you have to do something. But all of that gets repetitive, right? You always do, if this is null, do something else. Maybe throw an exception, bubble it up, or whatever, right? Then you do try catch. All of that becomes repetitive in a way. But the thing is, there are safer options to deal with these kinds of exceptions, especially in our situation. We just want to express that we do not have a useful value, right? There is a variant. You see readInt OPT. Look at what it's saying. It takes a unit, but it gives you not an int, rather an int option. You see, like, option is a type which is generic over the value. It just happens to be an integer. Okay. This option is you can think of it as a box. Have you worked with optionals in Java?
No.
Okay. You can think of option as a box, right? It's a box that is labeled with a type, and in this case, it's an int box. Okay, and this box of int is, of course, not the same as integer. You see? What I mean by that is, let's say, if it's giving you an integer, I don't know if null plus 4. Okay, it doesn't even compile. Yeah, what I'm trying to say is that when you say you return a null, there is still a chance that you can treat it as that object that is of its as that object. So you return a null, there is a chance that you will still end up treating it as a user, even though it's a null, right? But when you say that it's not an integer, there is no way to treat it as an integer. So let's look at this. I do readInt now, and then I do readInt plus 4. Okay, and then I actually type 1. You see, it worked perfectly. 1 plus 4 is 5. But what happens in case where I do not enter a number? It's going to throw an exception, right? This exception, you need to realize that this is a runtime failure. If this ends up happening when your program is running, it's going to crash if there is no handling for it. You see what I mean? Mm-hmm. But there is a difference here. readInt OPT, look at this. readInt OPT and then plus 4. What happened here? Like, it allowed me to enter a number, but look at what happens. It didn't even allow me to enter a number because it's saying, hey, this expression has type int option, but an expression was expected of type int. Why? Because going back to the definition of plus, you see it expects 2 integers on the left and the right, right? But on the left, readInt OPT, what is it producing? I gave it a unit, so the value it's going to produce is going to be an int option, which is not the same as int. So it's not even going to compile. I hope you got the difference. Like, readInt, it allowed me to read in all cases, but in some cases it just ended up throwing an exception, which is a runtime failure. But readInt OPT, when I used it, it said, oh, it didn't even allow me to read. It didn't even start the execution, right? In the REPL, anything you see in red, it means it's a compiled failure. In other cases where there are failures like this, they're runtime ones. Okay?
Mm-hmm. Okay.
Yeah, now it's clear that readInt OPT is a much safer function where any failure you do, you're not going to end up with a wrong program. You're just going to fail compilation, which is much, much nicer. Okay? Uh,
Mhm.
yeah, so it's forcing you, in a way, it's forcing you to think about the cases. Hey, like, yeah, so going back to the box analogy, it's a box that is labeled as integer. Now, you open the box, and either the box could be empty or it could have an integer inside. That's what it means. And adding something to a box of integer, of course, is not going to work, right? Even logically, if you think about it, it's not possible. Like, what does it mean? What do I add when the box is empty? What is the result? What result do I get? There is no answer for it. It's just not possible to do it that way. That's why it's a compilation error. Does that make sense?
Mhm.
Yeah. So read int opt. Let's see what happens. Like read int opt. If I do like 4, it's going to give me some 4. If I do something that is not a number, it's going to give me a none. Okay. Now, what is this sum and none? They are constructors. Not similar to Java's constructors. It's a little bit different, but you use those things to construct values of values of type option of type option. Okay, so option, as I said, is a box, and it's represented by 2 constructors. Either it's a sum value or it's a none, which is no value. So I can do something like, I can construct a value myself. I can do like sum a. You see what is the value? This is sum a, and the type is a character option. I can do sum and then give it a string, and then it's a string option. Okay, I can do none. You can see now it's a generic because I don't know what kind of a box I am. I just happen to be
Oh, okay.
any
Yeah.
empty box. It could contain anything. Okay.
Mhm.
Now, yeah. So OCaml and all these functional languages prefer this kind of an error handling where functions are very honest in what they return. Yeah. So just reiterating what this box means. The function says, I'll not give you an integer directly. Instead of me saying that I'll give you an integer, but sometimes I'll throw an exception, I'll just tell you I'll just give you a box. And now it's your responsibility to deal with that box. I'll give you a box of integers. A box containing an integer. Now you decide whether you want to, like, what do you want to do when the box is empty, and what do you want to do when the box has something inside, right? That's your call, and you have to do it. If you don't do it, if you try to treat it as a normal integer, the compiler is going to yell at you. Okay?
Okay, so it basically takes the original problem, which could turn into a runtime error, and it turns it into a compile time error. At
Absolutely.
worst, if you are gonna like get an error rather than it being occurring at runtime, it'll occur at compile time.
Yep. 100%. And we always prefer that because when we want our programs to run, we don't want them to crash, right? But
Mhm.
if it's compiling, that's fair. Compiler is actually guiding us to the right path. And then like you have a bunch of these kinds of functions, and option is just one way to deal with errors, especially what is option? Option is giving you the capability to say that we do not have a use. We may not have a useful value to return in some cases, and when it does happen, it's your responsibility as a caller of this function to deal with that, right?
Mhm.
Yeah. So that's one way. There's the I actually lost my train of thought. Yeah, so basically the idea is to make the functions more honest.
you were basically talking about how in Java, like you can return a null value and
Hmm.
um, that could be an issue. And like you expect something from a function and you get back something unexpected.
Exactly, exactly. Something unexpected in the case, null. So right, and then you end up littering all your code base with null checks and whatnot, and try catches and those kinds of things. So in Java, um, there is no way. Like when you're dealing with a large enough code base, and even when it says that it throws an exception, you cannot be completely sure. Unless you actually read through the method, there is no way to guarantee that you're not going to get a null, right? If you're just looking at the definition, even though it throws an exception, in some cases it might throw a null. It's just annoying at some point because there is no guarantee. You are forced to do a null check at one point, right? But there are no
Mhm.
nulls in the language. OCaml does not allow nulls in the language. There is no concept of a null, right?
Mhm.
Yeah. So options, again, are giving you an opportunity to express that there is no meaningful value. There's another thing called a result, and that is like this constructor. I can do some OK and character. You can see that it has two things. Like one is this, and one is a character, and the other is actually the error type. I did not give an error, but there is tick A means could be any error. I'll just use 0, for example. Right. In this case, option just says I do not have anything in some cases. Result says I either have a good value or I have a bad value. And this is the type of the good value and this is the type of the bad value. So this kind of error handling is preferred over exceptions in a language like OCaml. Okay.
Mhm.
All right. So we have a way to read these read integers from the command line. I mean, sorry, from standard in. We need to be doing it in a loop. Okay, so the original thing we were at, we're here, and then we shot off the tangent of understanding functions. So seek.iter is should be more digestible at this point. You can see that the first argument to iter is a function that takes a and gives you nothing, right? It's doing this side effect basically. So like print int, right? Takes an int
Mhm.
and gives you nothing. It gives you nothing, but does a side effect of printing to the console. And then it takes a sequence of a's. You see, like for this thing to compile, the function you pass should take an element of type A and give you and produce a unit, and a sequence of A's should be passed. So I cannot be like, I'll give you a function that takes an int and prints it, and I'll give you a sequence of strings. It's not going to compile because
Mhm.
this is clearly saying, oh, tick A unit, tick A to unit is a function, and then the sequence is also has to be of tick A. So it's just going to be a compile time error, and then at the end it doesn't give you anything. So this is exactly like a loop, right? The for loop. Um,
Mhm.
so let's see what happens though. We have a function which is like in this form, which is of the form int to unit. So we want a sequence of integers, and then we can pass this function, and we're going to see that effect right at the end. Okay.
Mhm.
Uh, and we saw that there's a nice way of constructing a sequence of integers. Let's try to do that. Seek.ints and let's say 4. Okay. We've got int seek.t and we've got int to unit. Can you help me call this function? Given that,
Yeah, so it'll be seek.iter, and then the first argument is satisfied by print underscore int.
Okay.
And the second argument, which is a seek.t, is satisfied by seek.ints.
Seek dot, not just seek dot ins, because
Yeah,
seek
no. Okay. Seek ints.
is actually a function, right? It's not a sequence. See, it's
Oh, okay, okay.
look
Yeah.
at the shape of this. Oh, sorry. Look at the shape of this. It's a seek.t. It's a seek.t. But this is not a seek.t. This is actually int to int seek.t. But here we have int seek.t. Right? So we need to pass
Yeah.
4.
Okay, yeah.
But
Yeah.
like it's going to like look weird now. It's the first argument, the second argument, and the third argument. But this is actually one, right? So we have brackets here.
Mm-hmm. So you what, loop 4 times or something? Oh.
Oh, yeah, that was my understanding. I apologize. So seek.int, what's gonna happen here is actually seek.ints. It takes a starting number and then it produces a sequence of integers starting from there. Okay.
Okay.
Yeah, I can do
It takes a
something.
starting number and then okay.
Yeah, and then it keeps producing. Like it goes on forever. That's what a
Okay, that
sequence
was
is.
gonna be my
Like
next question.
yes, yeah. So sequence and lists, right? Lists are like bound. You know, you have a size for a list, but sequence, it really doesn't bother. It could have a size internally, but sequence doesn't give you, it doesn't expose the fact that it is of this length, right?
Oh, it's kind of like a stream, maybe.
Yes, exactly. It's exactly like a stream. Have you worked with streams in
Oh,
Java?
okay. A little bit, yeah. I don't have a good handle on them, but I got a rough idea of what they are.
Okay, okay. That's decent. I mean, it's enough to be able to relate to a sequence. A sequence is a stream. So even in Java, streams will have a certain type, right? And you will have a stream of integers. You can have stream of objects. You can have stream of your custom types, whatever, right? So that's what
Yeah.
a sequence is like a stream in Java. And it's again parameterized by a type, just like in Java. Stream of ints, int seek. Stream of strings, string seek. You can have that, right? And there's this interesting function called of dispenser. Interesting in this context, okay? What is it saying is taking a function that takes a unit and gives you take a option. Can you think of a function that we've already seen that satisfies this?
Print. No, wait. Print actually takes something. No, it does.
We can check that. You want me
Hold
to
on.
show you print int?
Yeah, could you show me the signature again?
Yeah.
Int unit backwards. Okay, so what about read? Could you
Yeah.
show me the signature for read?
Read int.
Yeah.
Yeah.
Yeah, that looks good. Oh, and then you can do the box thing that you were talking about. Because tick A just represents any data type, which could be int, that's fine. And then option is maybe you could do that box thing you were talking about.
We can, but we've already seen that actually satisfied. Just like we readily use print int in our earlier abomination of the call, right? We were able to pass print int there. So there is a function that we can already pass here.
Read read int?
Read int is not passable. Like I cannot do. I mean, as soon as I do this, seek dot of dispenser, I can pass read int, right? It's going to complain. Oh, this type takes a unit and produces an int, but an expression was expected of unit and produces tick a option. But look at this. Type
Okay.
int is not compatible. Like I hope you're able to get like get some sense of how the type system is actually working. It's drilling down and then finally telling you like where it actually fails. It is saying type int is not compatible with type tick a option. So
Hmm.
yeah, let me just do this. So what other function do you want to try?
Um, what other functions do we have? I forget. Oh, option. Read
Yes,
int option. That's
there you go. There you go. So we have a function unit int option. So you can assign like now we have tick a is int, and then we have a way of producing. Sorry, it's saying that you give it a function that takes a unit and returns an int option, and it's going to give you a sequence, right? If we give it this read int opt, what is it going to give us? Like, can you guess the type of type we're going to get back? If I give it seek dot of dispenser, and then
um
I just do this, what do we get back? Just
well
reiterating, you give it a function, and you give it a function of this form, and then it gives you a sequence. So our function is of this form. So what kind of sequence are we going to end up with?
a sequence of int options.
Really?
Yeah, I'm feeling pretty good about that.
Ah, but there's a slight miss. Look at this. It returns tick a option. Like, what is tick a in our case,
Int.
right? And what is tick a here? It's going to be an int, right? Why would it be an int option?
Oh, oh yeah, good catch. Okay. Man, I was feeling super confident about that one too. Okay, yeah, fair enough.
Yeah,
Um,
look at this. Look at this. It's going to give us int seek t. Okay, so we get it. It's so nice. Now we have. Oh, this is like your. I remember we had a conversation about Lego blocks and composition, right? This is exactly what we were doing. Where we have a block, right, and then we are passing it to another block that fits right in, right, and then we get something else. Are you getting the sense of it?
Yeah, I'm getting the idea that you can, so option gives you that flexibility, right? It gives you the box where it basically says it might have something in it that's what you're looking for, but it might not have what you're looking for.
Oh,
But
sorry.
um
That was the understanding of options, but here I'm generally talking outside of options, outside of everything. I'm just talking about the compositionality. Like we just happen to be dealing with boxes at this point, but you can see how we've been dealing with signatures and how we're trying to fit things in, right? We read the signature, and then we see what we have at hand, and we end up producing a block that actually fits in that place, right? I was
yeah,
working.
I get exactly what you're saying now. Yeah, 100%. I get it. Yeah, I see that.
Right, right. So we've got we've got a sequence of integers. What are they going to be? We'll see. Uh, yeah, but you see that it might have raised a concern. Like I did say read int opt, but it really didn't start reading. Right? It hasn't asked for input yet. It just gave me a value of int sequences in int sequence, a value of an int sequence. Right? um,
Hmm.
there's no reading happening, and it's the same thing. Like if when I do read int opt and then I just evaluate it, it's just a function. Like it's obviously not going to read. For me to uh, actually want to be able to read, I would have to provide it a unit, right? It's not.
Parentheses.
Sorry.
Sorry, go ahead.
Yeah, so you see that when I just evaluate read int opt, the function is going to result in the function value. It's not going to do the side effect yet. It only does the side effect
Hmm.
when I give it an argument,
Yeah.
right? That's why
Hmm.
like we do not have anything here. All right, so we've got a sequence of integers. Now there is yeah, and then we have a way we have a way of iterating over that sequence, right? Now let's actually do this, okay? Let's do seek.iter. And what function do you want?
Read an option.
No, here for seek.iter.
My bad. So we got tick A and we got units. So we want nothing back, but we want something provided. That would be what was it? Print.
Yeah, we have print int here. And what's going to be the sequence? Our sequence is going to be the one we produced up here, right?
Mm-hmm.
Uh,
Option, yeah.
yeah. And I have them here.
Sequence. Yeah.
Right. So does this make sense? Like, of course, like I need these brackets because then it would have taken this as an argument and this as another argument. Okay.
Mm-hmm. Yeah.
Yeah. So now you see that print int is int goes from int to unit. Print int goes from int to unit, and then we have we need to have a sequence of integers. Of course, like when I do seek.after dispenser read int opt, it's going to be a sequence of integers, right?
Mm-hmm.
So this is going to type check, and we're going to get back. What do you think is going to happen?
I think it'll compile.
Yeah, it'll compile, but it'll also run, right? Because it's going to start
Yeah, and
evaluating.
then you'll have to probably have to start typing in numbers,
Perfect.
and then it'll print it out.
Yeah. Let's go. Let's type 1. Oh, it printed 1. Let's type 56. Printed 56. And let's type in 8. Printed 8. Is there something you want me to type?
Try typing a letter.
Boom. It ended.
Mm-hmm.
You see what's gonna happen? Like when I do this, I enter this. Oh, our loop is over. I enter anything that cannot be converted to a number. Our loop is over.
Mm-hmm.
And can you tell me, like, what's OPT going to return when I enter this?
Well, it's more flexible. It's not gonna it's probably same thing, like unit equals parentheses because it's not an int, it's a letter.
Wait, sorry. More specifically, can you recall? Okay, now when I do this, it's reading an integer, right? It's executing. It's waiting for me to input. What's going to be the return value when I press enter now?
Char, or hold on, let me think. This I know. So this one was what? Tick a unit. The
Let's
return
actually
value.
let's actually check the type of this. So it takes a unit. Let's give it a unit. Read int opt. Let's give it a unit. Execute it, and now I'm gonna do
Int
this.
option.
Yeah.
I think it'll just end like the same way the loop did. It'll just end the program.
Not really. I mean, let's go back a little. Let's do read int. What's going to be returned? What's going to happen if I press W and hit enter?
Crash the program. It's gonna show up in like yeah, it's gonna crash the program.
Perfect. Now, what if I enter 8?
That's fine.
Oh,
It won't.
yeah,
it'll just read it.
Yeah, can you just recall and tell me like what it's going to look like? The entire line.
Yeah, it might be something like hyphen.
Yeah,
No, actually, I can't. I don't remember.
hyphen is correct. You can just go ahead. You can see.
Hyphens.
Yeah.
hyphen read int semicolon equals bracket function, maybe something like that. Oh, I swear. Okay. It assigned. Oh, okay, right. It just assigned like the default, like a nameless. It binded something, right? The binding. It binded.
Yeah, it returned a value. So readInt, readInt again. Let's go here. ReadInt takes a unit, gives us an integer, right? And then we give it a unit, and then we entered something, and it gave back an integer, correct? And in cases where it couldn't parse it, it would throw an exception, failure, right? What's gonna happen in this case if I enter 8? What's it going to?
It's gonna show up that stuff in red where it's gonna say it expected a type of this, but you supplied the wrong one. Oh no, wait, my bad. You are supplying the right one. So right now it'll probably just do the same thing read int did. It'll just do hyphen colon int equals 8.
Is it going to be int or is it going to be something else?
Oh, tick. Yeah, it was a tick, wasn't it? Oh, read int. Option. Okay, so it's gonna be of type int option.
Yes. Look at this. And the value is sum 8.
Uh-huh.
So
The constructor.
let's pedal back and look at a simpler type, which is Boolean, right? How do you construct a Boolean? You say true, you constructed a Boolean, right? You say false, you constructed another Boolean, right? How do you construct an integer? You just write an integer. Okay?
Okay.
How do you construct a string? You say double quotes. You have some way to construct these values, right? So the semantics are different for different types. Same way, you have 2 ways of constructing an option. Can you remember those 2 ways?
Yeah, some and none.
Exactly. So you can construct an int option by doing a sum and then giving it an integer.
Okay.
And none, you cannot provide any value to it. So it's always going to say, oh, it's a box that could contain anything. It just happens to be nothing at the moment, right? So a readInt OPT is going to do this construction inside its body and is going to give you that box as output. Instead of giving you an integer as output, it's going to give you an int box as output. Okay?
Yeah.
So now, can you tell me what does readInt OPT give you when I give it A? When I enter A?
It's gonna give you none. Well, it's gonna give you an int box back.
Yeah, but the value, what is it going to be its value?
None.
Perfect. And what about 42?
Yeah, sum 42.
Perfect. Right? Okay, so let's look at the sequence we constructed, right? We did seek.iter, print in, seek.ofDispenser. Okay, so exactly like the way you understood, like iter is like looping, and what is it doing? It's iterating over the sequence and then executing this function on every value inside the sequence. Okay? We've got a sequence of integers, and then we supplied it a function that knows how to print those integers, right? So it goes through the sequence and ends up printing each integer. Okay, let's make it I'm trying to see like how to go forward. Let's actually make it a little pretty. Let's print a new line. Okay, it's weird right now when I do this 4 and then this. Okay.
Okay.
And you see, like, when the sequence ends, we already discussed. I just wanted to recollect what we, well, yeah, what you understood. So when does it end? It keeps going on. Like I can give 1, 2, 1, 0, any number, right? When does it end?
When you give it a int option of value none, like when you give it, yeah, basically anything that's not an integer.
Yeah, yeah. Because the user doesn't really need to know whether it's a box or something, right? User's only job is to enter some values, right?
Hmm.
So, uh,
When you enter q, it could
yep,
end.
yeah, it can end, or it can end at s. Doesn't matter. When does it
Yeah.
end is decided by of dispenser, right? Let's revisit the function. What is it saying? You give me a function that produces options. Okay.
Hmm.
You give me a function. What is this function? In our case, readint opts are function, right? Readint,
Hmm.
and you can see that you just substitute this a with int. It fits right in place for seek dot of dispenser. When you do this, you seek dot of dispenser's guarantee is that I will give you a sequence of A's if you give me a function that knows how to produce a box of A given the unit. Does it fit well with you?
Could you repeat that?
You supply
Just the
a,
last thing. I will. Yeah.
yeah, uh, the function needs to know how to produce box of A's,
Hmm.
and then you supply that function to seek dot of dispenser function. It gives you a sequence of A's. Okay.
Okay.
So just yeah, similar idea of burning this thing in, right? You burn this here at this point, and what does int become? I mean, sorry, tick a becomes an int, right?
Hmm.
Which means you're going to get back an int sequence. That's exactly what happened. Like when I just do this, it's an int sequence, right? You see like how it fit right in. So we're
Yeah.
able to get a sequence of integers. And seek.iter, it can take any function that knows how to consume a, and then you give it a sequence of a's, then it's going to consume every element in that sequence. That's what it's saying. Is that clear?
Hmm.
And we were able to
Yeah.
execute this fine, just fine, right? Everything was able to compile and it was able to also run. Just that the way it was printing it was a little weird, right? So we want to fix
Hmm.
that. Now we can pass it a function that knows how to consume this a. So what is a in our case?
In.
Yep. So we just need to come up with a function that prints a number and then enters a new line, and also prints a new line. Okay. Let's work on building that function. Sound good?
Hmm.
So you have printf. You should have worked with printf, right?
Yeah.
You do this
Hmm.
%d, %d, and then you give it a number, and there you go. It prints it. But
Hmm.
let's add a yeah. I mean, let me ask you this: how would you add a new line to this?
Backslash n right after the d.
Perfect. There you go. You see, like the difference here: hyphen right beside for, hyphen comes on a new line because we printed new line. Okay. Now my question to you is, how do you, like, what do you do to make this fit in this place?
Okay, so 4 can be replaced with read int. Yeah, because right now we're hard coding 4, but in the actual program, we're going to take that in from user input. So user input is going to replace 4. Um, and then printf is going to take the place of seek.iter, where it says print underscore int. We're going to use our new function that we
No,
just
no, no,
made.
no. That's
Oh.
yeah, that's not the way we want to go. Can you tell me like what is going to be the signature of this?
Yeah, it's gonna be, so you give it a number, so it's gonna be int, and it gives you back nothing unit. So it's
Yes.
probably int unit.
Right. So it would be something like this, right? Int to unit.
Hmm.
Do you agree?
Yeah.
Perfect. That's it, right? We already have this. We just need to supply this instead of print int. You see print int and this have the same signature, just that the way they produce this unit, the side effect is different, right?
Yeah. Okay, so then would it be sequence dot iter capital
Yes.
printf
Yeah,
dot
yeah,
printf
yeah,
and
yeah.
then parentheses sequence of, okay,
Print, yeah,
sequence of
just go on, go
dispenser.
on, go on.
Um, oh, you did quotation marks. Okay, so is that gonna be, okay, percent %d backslash n.
Percent %d backslash n. Okay.
End the quotation mark,
Mm-hmm.
and then space, parentheses, and then inside of that put sequence of dispenser, and then read int option.
Read an opt-in. Okay. Do you think this is going to work?
Um, well, the fact that, so print int is one argument, maybe you should put parentheses around print, yeah, and then,
Exactly. Exactly. There you go. Time to test. Big
yeah,
number. It printed it, and then also the new line,
yeah, the new line too. Nice.
right? So you didn't have to really think that much about it. You just had to understand the system to be able to fit things in, right? And then I just pressed
Mhm.
Q. I could have entered anything, right? I could have entered
Mhm.
anything, just reiterating, right? And then end sequence. Okay, so uh, let's pedal back again and understand the option. Okay, what is it used for? It's used for indicating that in some cases I do not have a value to produce, right? Let's look at of
Yeah.
dispenser again. It's expecting a function as an argument first, and that function, you can think of that as a producer. ReadInt is a producer. ReadInt opt is a producer. Read string is I think it's read line. Read line is a producer. Let's have this notation. I mean, let's have this term defined where a producer is anything that takes a unit and gives something. It doesn't matter what it gives, right? So readInt is a
Okay, so a
producer, which,
non-void function.
yeah, readInt produces an integer. ReadInt opt produces an integer option. ReadLine produces a string. Okay, but here seek.ofDispenser is saying that you give me any producer function. The only constraint is that the function should produce a box, not the thing itself, right? But produce an option. So in our case,
Mhm.
this is the only thing that satisfies it, and our a is an integer, right?
Mhm. Yeah.
There are other things. There is a read float. Just a small quiz. Like, do you think this would fit in here? Can we pass read float to of dispenser?
Um, yeah. Oh, no, because it's missing the option. It, like, the tick A float, that, yeah, no, you can't. You'd probably have to do read float underscore opt in order for it
Perfect.
to.
Yes.
Yeah.
Yeah. So let's actually go go do this, but instead of int opt, let's do float opt. You know that we can't just pass float, right? Read float, because that is producing not a box. It's going to just give you a float, but we need float option, right? Okay, so
percent.
exactly. So here of the function is going from an integer to unit, right?
Mm-hmm.
And oh my god, fd. There you go. So we'll see, like you must have already guessed the signature of this. We'll see 4, it's 4.000 and 3 more zeros. It's producing
6.
floats, right?
Yeah.
And then I press anything that is not convertible to, oh, I could have just 1.6, right? 1.894, right? It's able to do that. And then I enter anything that cannot be converted to a float, it exits. And yeah, just to be complete, I'll just do read int opt and then change the f to a d, and I give it like this. It's going to fail because it's not an integer, right? Read int opt fails at that point. Okay.
Mm-hmm. Yeah.
Yeah. Going back to off dispenser. Yeah, you give me any producer function that knows how to produce a box, and it says that I'm going to stop producing values into this sequence when your function says that it does not have a value.
Mm-hmm.
So how do you construct an option to indicate no value? Can you tell me that?
None.
Perfect. Exactly, right? So, and when does read int opt or read float, read int opt, when does it produce a none?
When you pass it something other than a number.
Perfect. And now you should be having a pretty good understanding of why the loop is ending.
Yeah.
Right? Okay.
Yep.
So,
So really, our loop is really just an infinite stream that once we pass an invalid value, it breaks. But in essence, that's the same thing as like a loop.
yes. Yes, it is. And the loop is actually triggered by a certain class of functions, actually. We might want to get in there, but that we'll see. We'll see how that goes. But seek.iter is the thing that is triggering the execution. If I, as you saw earlier, right? If I just do seek.offDispenser, if I just executed this part, I mean, if I just ran this part, it gave us a sequence of integers, but we weren't really reading integers. Remember?
Mm-hmm.
When you just say this, it's a sequence of integers, but there is nothing produced in the sequence just yet. The production only starts because of iter. That's something we might want to discuss later, depending on the state of both of our minds. For now, it's good enough, right? So you give me a function that produces a box, and box of A's. I'll give you a sequence of A's, and how long will the sequence be? I'll keep giving you A's as long as your function gives a box of A. As soon as your function says that it has nothing to produce, I'm going to stop producing the sequence, and that's when it ends. Okay?
Uh-huh.
Right,
Yep.
so we're starting to come closer to, yeah, we already have a looping construct, but it's much more declarative. You see, like, we are not saying for do this, and we're not doing the how part. We are doing the what part, right? What do we want? Well, we want read int opt. just for correctness, this analogy might break, but it's a decent way to understand the difference between declarative and imperative. Okay, we want to read int opt, and then this is and we know how to print each integer, right? Or the printf thing, right? And then we also do the iter. Okay, before we move on to actually solving the problem, I'd like to talk about cosmetics, right? This can get messy, okay? What I mean by that is when you have these brackets, it definitely is more tedious to write, okay? Um, let's recall how to define a function. And can you tell me, like, let's define a function called inc that takes a number and then returns another number which is incremented by 1. Can you recall?
Okay. So yeah, I think it was let inc
Yeah.
space 4 equals, and then 4 plus 1.
Oh, but that.
Or wait, hold on. But the thing is, you're hard coding 4. You said you wanted to take a number, so how would you? Oh, x
Yes.
equals, and then x plus 1.
Yep. Perfect. Okay. Um. Let's do this test. Okay. What was the contract? Increment said, you give me an integer, I'll give you back an integer. And what are the properties of it? It just happens to be incrementing the number that you gave in, right? So let's say you want to increment it twice. How would you write it?
You want to increment plus 2?
No. You only have one function, and you want to use this function to increment twice.
Oh, okay. Then you said that you can pass functions as arguments to other functions. You can pass them as values. So I would just call increment twice, and one of them would be like the argument of another. So it would be like inc parentheses and then inc whatever number you want.
Okay, this is not really. This is not exactly passing a function. We're still a value. Just technically correcting you. Yes, what you said was right, but it is not relevant in this case because we're not really passing functions as argument. We are still passing values, right? What is this? Inc4, what is it going to produce? It's going to produce a value of an integer, right? It's not going to produce a function. Because you see that inc4 produced an integer. It's not a function. There's a difference, right? Inc4 produced a function, and now you supplied this to an integer to inc. What you understood was right, but just not relevant in this case. Okay, right? So it incremented it twice. So let's do it thrice. Can you tell me how you would go about doing that? I know
just nest it again.
Yeah. This is going to be the last level. So yeah, you just tell me the characters.
Okay, so it's gonna be inc open and close parentheses. Inside of that, do inc again. Open and close parentheses. And then inside of that, do inc and then pass the number that you want incremented 3 times.
Perfect. It works, right? Okay, but you see the parentheses problem? There's a very cool operator in OCaml called the reverse application operator. Okay? Inc4, this is an application, right? Which means you apply the thing on the left to the thing on the right. You apply inc to 4, and then you get back. Now, how would reverse application look like?
Maybe a factorial or something.
No, reverse. I'm saying that just the visual representation of the reverse of this. inc4, what would be the reverse of it?
Uh,
4 inc, right?
oh, yeah,
Yeah, visual
yeah.
representation that is a reverse of this. But of course, like this is not going to work. It expects this to be a function, right? It's an integer. Like when you do inc4, why does it work? Because inc is a function that has the capability of consuming an integer and producing an integer. So of course, it knows. It has a way to consume a number, and of course, it's going to be able to take in a number. But here, it says, "Oh, this is not a function at all. You cannot pass this like this." So there is a cool operator, which is the reverse application operator, as I said, which is this. It looks like pipe. Let me. So this is the pipe operator and the greater than symbol, and inc. What's going to be the output?
Let's see. What is going to be the output? Because you're passing it 4, but how many times are you incrementing it? Just once, maybe?
Yep.
Maybe
Yep.
5?
Yeah, it is 5.
But there's got to be, but I'm sure there's some sort of like multiplier where you can add another number and that'll tell you how many times you want it nested.
We'll
Oh,
get to that. We'll get to that. But I'm saying this. Look at how clean this is.
okay. Okay, comparative to the other. Okay,
Yeah,
I
you don't
got
have
you.
parentheses.
Mhm.
You see, like it's just
5,
a
yeah.
reverse application. You use this operator, so you can just imagine that you're supplying 4 as an argument to this right hand side. That's it, right? So what's going to happen is 4 is going to get supplied to inc, which is 5, and this thing is going to get 5. This thing is going to get supplied to inc, right? And this thing is going to get supplied to inc. This thing is, you see, like it
Yeah.
chains nicely. And
The thing on
okay,
the,
yep.
yeah, I was just gonna say that, okay, yeah, I get it.
So, and here's the reason why you need these double semicolons. If you worked with REPLs like JShell or Python REPL, right? They're all like line separated. So when you hit enter, the evaluation triggers. But OCaml REPL allows you to do it in this fashion: inc, 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 and then when you're done, you do this. I hope you were able to make sense of why double semicolons make sense. I mean,
Yeah, because the default behavior in OCaml JShell is when you hit enter, it doesn't execute the line. It just goes to the next one
yeah,
until it
yeah,
reads the double.
exactly,
Yeah.
exactly. And there is a single semicolon which is for side effects. So I can do stuff like print end line of h single semicolon, print end line of e single semicolon, and then double semicolon. And then double semicolon. What? Oh. What? End line.
You just missed it. Yeah.
There you go. You see, like, semicolon is for actual statements, like side effecty things. But yeah, I think that's enough information as to why double semicolons make sense, or why you're actually forced to do it. Because OCaml REPL allows you to do multi-line inputs. Okay? Right. So this thing is cool. Now, how would we rewrite our original sequence and then printing sequence thing, right? How do we do that? So it's very natural for us to think it in that way. So what was the first thing we had on our hands? We had a read int opt, right? We have read int opt. And what we want to do, we want to pass it to sequence.ofDispenser. Okay? And now at this point, we have sequence of integers, right? This one, we want to print f %d new line. Oh, sorry. Is this the right? No, we want to iterate, right? We want to iterate. And oh my god, yeah, this is my carelessness. You still need brackets here because they're different. They're not different arguments, and there's going to be printf.printf.
Mhm.
All right, read into PT. I'll just say 1 and A, and I'm done. Compare it to the printf we had earlier. You see, like, how this simplifies things and it actually results in a nicer, more readable code. It will take some time, but once you understand it, it's going to be much easier. Okay, but it's prettier, right? You read into PT, you pass it to seek.ofDispenser, and then you pass it to seek.iter. That's exactly what's happening, but then you're using the pretty cool reverse application operator.
Yeah, it kind of looks like streams.
It is streams. You do the dot 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 on a
Yeah.
line. I mean, you on different lines, right? It is. It is because yeah, we have a stream of integers. How did we produce that stream? By using read into opt and this of dispenser function, we produce a sequence, and yeah, which is analogous to a stream. And that stream, you're iterating over that stream, printing each element in the stream. And
Yep.
because they're integers, you pass the function that knows how to print an integer. That's it, right?
Mhm.
Okay, so how close are we to doing this? Uh, there is a concept
Well,
of yes.
I was oh okay. I thought you were asking me. I was gonna say we like so far. We pretty much have everything we need other than the actual calculation. But as far as like getting input from the user, we have that. Instead of printing, we don't need to do that. We could just, in place of printing, we could do the actual calculation, which would just be summing up each new additional number that the. But my bad. I thought you were asking me.
No, that's fine. That's cool too. Yeah, so we'll eventually, I mean, my goal is to exactly build a program that does this, with all kinds of, I mean, with the exact replication, with the replication of this. So I'd also want to print that it's not a number, but that's how, like, first we'll have anything that we'll just read numbers and then print a sum, and then we'll eventually keep adding these things on top, right?
Mhm.
We're getting there, right? And your analysis of the progress was pretty good. Okay,
Mhm.
how do you calculate? Have you heard of folds?
Folds, no.
There is something called fold left. Okay, it
Mhm.
looks, it might look daunting, but you might get a sense of like what it's expecting. Can you tell me what the first argument is?
First argument, it was the okay. So it
By the
looks like the
way,
first argument.
tick A, tick B, tick ACC, tick X doesn't matter. It could be anything. Just like
Okay.
your list of T can be list of element. Also, doesn't matter, right?
Yeah. Okay. So it looks like the first function it expects two generic types and it returns the first generic, or I'll just call them generics. I don't know if I'm actually using the correct terms, but it takes two arguments and it returns the type of the first argument.
Yeah, returns a value of the type first argument, technically. Yes. Perfect. That's actually a perfect
And,
understanding. Yeah?
and then okay, the second argument is just another generic, and the third argument is actually taking in a sequence of the second argument. Okay, so so this function returns the first argument, and then the second argument is that too as well, and it returns, or sorry, and it also takes in a sequence of A, and it returns the first argument again.
Yeah.
Okay,
So
so I'm
it.
guessing because you're introducing this, this has something to do with like summing up. So let me see how if okay,
Mm-hmm.
let's say we have so we
Mm,
take input from the user,
mm-hmm.
um, which may be ACC, and then okay, so the input from the user is probably the function, and it's gonna return the input from the user, and then we're gonna take that as a second argument, and I don't know what this is doing actually. I don't know.
Yeah. So there is I have seen this in your understanding. You really start from the beginning. You don't really have to think about input at this point because you don't have it at this point. I mean, you already have the input at this point. You just need to think about what you're going to do with it. Can you tell me
Mm.
uh, what can you tell me what are we ready with in terms of the arguments? Do we have this kind of a function? Do we have this value, or do we have sequence? Well, out of these three things, what are we? What do we already have? Can you tell me that?
We definitely have a sequence.
Yeah,
Um,
and yeah, what kind of a sequence is it?
numbers, and it's guaranteed to be numbers because the function, the minute it
Yes, yes,
returns a
yeah, yeah,
non-number, the sequence is gonna be like, nope.
yeah. So, can you tell me the type exactly? Like, what is it? Let's
Int.
actually let's actually start with the file now. I'll call it total.ml. And right, so we have this thing uh, with us, right? So you let's actually go to this. Okay, so what kind of a sequence do we have? Can you just write tell me the type of it?
Int sequence dot t.
Perfect. So we've got int seek.t. We have this. All right. So what? So if you burn this argument in, what is going to be tick A,
Int.
right? So everywhere there is tick A is going to be an int, right?
Yep.
So I thought I was smart, but yeah, this you understand that if this A is int, this is also going to be int, right?
Yeah.
And this is also going to be int, and I can just erase this, right?
Mm-hmm. Yep.
Well, wait. Let me update my editor because I know the newer version of Helix has better error reporting. All right, so while that compiles, right, so we have this. Okay, so we've got in sequence, and can you think of this? ACC is short for accumulator. What are we accumulating?
It's like the running total. We're
Yes. So
accumulating each user input.
yes, yes. What is the type of it?
Int option, I think, because at that point we don't know. Well, no, hold on. We won't accumulate it until we guarantee that it's a number, so it's also
Yes.
int.
Yes. So you agree that ACC is an int. Does that
Yeah,
fit
I
well
do.
with you? Right? Okay, so
Yep.
we just have to now think about um let me just write it. Okay, it's almost done. Until then, I'll just total.ml. Right. So do we can you think of what functions fit in here?
Yeah, hold on, give me a second. Given with what we're doing, where would we need? Oh yeah, for sure. Add. We would take two
Yes.
arguments, add the number, and then we would return a number.
Perfect. Perfect. All right. So let's actually start doing that. Um, okay. This is what I was saying. Like, its syntax. Sorry, error reporting is much prettier now, which is cool. Okay. So we have this. Let me comment this out. And this is how you comment stuff in OCaml, by the way. All right. So can you help me? Remember what we wrote so far, the pipeline.
Yeah, we start out with the thing that gives us the box, which was sequence.iter, and then we have sequence.t, which is the thing that takes the box and
No,
the
sequence dot
stream
iter.
basically.
No, do you remember the reverse application operator that we used? What did we start with? We started with read and OPT, right?
Oh yeah. Yeah. Um, the reverse.
Read and OPT, and then what are we going to supply this to?
We are going to supply that to the option. So we're gonna supply it to, let's see, we have iter. We're gonna supply it to iter.
Oh, no.
Oh, that's right. Sequence of. It started with a D. What was it?
Of
Sequence of
dispenser.
something. Dispenser.
Yeah, this is one, and then of dispenser. The earlier one without the reverse application was like this, right? So we've got read into OPT. We need to supply it to of dispenser. So with the reverse application, you just do it the other way, but then use the operator, right?
Yeah. So it's
Okay,
gonna
read
be
into
read
OPT.
in, then it's gonna be the
Yeah.
pipe and greater than, then it's gonna be sequence of dispenser.
Okay. And then it's going to be pipe and what are you going to supply this to?
Uh, the thing that was to the left of that. What was it? It was okay, right there. Print seek iter. You're gonna supply it to the iter.
Yes, that's a great catch. Seek.iter, and then it's going to be printf.printf and %d/n. All right, we have this. Let's actually, we can keep this around, but I'll open another terminal and let's try to run this. Now this is in a file called total.ml, right? Oh, it's running. Let's type in. Let's 4, 6, 8, 0, A. Done. Okay. Now, what are we going to do? Like, we don't really want to iterate, right? We don't want to iterate. We want to do this operation. And where did this come from? This is actually the sequence.fold left, right? Okay, so we already have. I can do something like sequence.fold left. Yeah, so we've got like 3 values here. We've got to supply the function, and then we've got to supply the argument, and the sequence is going to come from above, right? Because of the pipeline, right? It's going to come from above. So you can see. Yeah. So what do you want this one to be filled with?
I want that one to be filled with add.
Yes. Okay. Add, and then what is this? Oh, add. We don't have an add. Let's actually define the add. Let's go. Define the add. Can you tell me?
Add xy equals x plus y.
Perfect. Okay. We've got this. What is it complaining about? But an expression was expected. All right. So we've got add, and then what?
And we need to do int.
What should the integer be?
It should be the result of the addition.
No, we don't know the result at this point. Do we?
Okay, so then it's gonna be sequence dot dis. No, hold on, wait. I think I see the pattern. So you sequence fold left is expecting 3 arguments, and right above it you have 3. So if we fold left, the next one is gonna have to be int, which could be.
What should it be?
It should
Can
be
you?
what the user types.
No, no. User is typing in here.
Oh
Um,
shoot.
what was that? What was the file name? Some stream.java. You've done it here, like in this program. Do you see the integer that you already know?
Hold on, give me a second. The integer that I already know. Sum?
Yeah. What is the value of it?
0.
Well, what can we put in here?
0.
So I have to remove this. Sorry. What is it saying? Read into OPT. If this is a recursive function, these errors are weird. I don't. So I have to do this. Sorry, I have to do this kind of a thing. I'll explain this in a bit. Give me. This question is type. Okay, so at the end of this, okay, so what we satisfied this constraint, right? What is going to be the return value at the end of this?
The return value is going to be x plus y.
No.
Are you talking about add or at the end
No.
of what?
So we started with this function, okay? We started with seek.fold left, and then I asked you like, what do we have so far? You said we have a sequence, and then I asked you like, what type of it? What type of a sequence is it? You said it's in sequence. Then we substituted a with int, right? And then what happened was what did happen? Like,
We substituted the add function.
Yeah, we substituted the add function, and then everything turned into an int, right? So we ended up in this situation. Now, what is going to be the result of this? I mean, so let's say your accumulator is an integer, your a is an integer, right? And what is going to be the return value of this?
Integer.
Yes, perfect. Now, what do you want to do with that integer in our program?
I want to. We haven't added. Well, I want to add it again to the next. No, I want to store it actually. I want to store that value.
No. Just think of the program. Do not go to the low level of where do you want it to be. What does the program do? You give it a, I mean, the user gives a sequence of integers, right? And then you sum them up. And then what you do? After you sum them up, what do you do? What?
You return the total. Or you print out the total.
Exactly. And do you remember the function to print?
Yeah. Capital P printf dot lowercase printf.
Okay.
And then you pass the string argument, which is going to be double quotes inside %d \n.
Okay, so you just need to remember that the reverse application operator is going to work like this. You give it like this, right? You don't supply the argument later. It's actually coming from behind. So this thing coming from behind, you need to read it that it's like writing this here. You see what I mean? It's like this.
Yeah, so what's in the parentheses is actually behind it, is how I need to be looking at it. Like the value behind it is going to be the argument for the following function.
Yes, perfect. So yeah, this is what you need to, and underscore is like ignoring the value. That's it. You don't care like what really gets returned here. Here you're binding a name, okay? Here you're not really doing anything. You can do stuff like, I don't know if you can do this, let this equals 4. You can, right? It's like ignored value. You really don't care. But what are we doing here? We're doing a side effect. It's not a matter now, but yeah, we have let add, and then we have this. Okay, what is this is going to be a unit because we are printing at the end, right? It's going to be a unit. Okay. Any questions so far? We'll get to like how fold is working in a bit, but let's see what happens now. Good. Okay. Let's start. You give me the input.
3,
Okay.
2,
Okay. Oh my God. 3, 2.
5, and then you could do Q. So it should be 10, right? Yep, 10.
Oh, we're almost there, aren't we?
Yeah.
Okay, so do you remember that I said, like, whenever you have an operator like 2 plus 3, the plus, right? You can use it as a function. Like this. So we can just do that. Oh, I can just remove this, and here I can do plus. And nothing's going to change program-wise. It's going to behave exactly the same. 1, 2, 3, A. And it's going to be 6. Okay? And in your case, sum stream, in your case, you're printing it that way. Let's actually make it like this. Okay? Brings us a little closer to the goal. 1, 2, A. Okay. And let's actually divide this terminal and do Java some. And here it's going to be like 1, 2, and A. It's going to, yeah. Oh, in your case, like it's not going to exit at the wrong input. It's only going to exit at Q, right? Or Q. Correct?
Yep.
All right, so let's actually see how we can do that. Okay. Now, reading OPT is not enough for us because it's going to say, hey, I do not have a value to produce if you give me something that is not a number. Okay? We really want our custom function, which only says that it has nothing to produce when the user enters Q. Is that clear?
Okay. Yeah.
We want a function. Let's say we want a function called read, and it should take a unit. It's like, this is how you say it takes a unit. And what it should produce is, what should it produce? Should it produce, let's say we have a function that produces string options. Okay. By the way, that's like saying this is how you specify the return type for a function in OCaml. You do a colon. If I want to do it for add, let's say inc, I want to specify all the types. I can do inc x. It takes an integer and it returns an integer, and it does x plus 1. This is a syntax of specifying actual types. Even if you do not do this, the type system is smart enough to understand it. But sometimes it helps. Like when you're writing it out, it's nice. It's nice to specify them. Like you read it and then you immediately see, okay, what it's going to return. Okay. So is this clear? Like I want read to take a unit and return string option. Is this clear? And then if let me also, for completeness, takes x, which is an int, takes y, which is an int, and then it returns an int, x plus y. This is correct, right? And then if I go this, there we go. And then if I do this float, it's going to fail. Hey, this expression has type float, but an expression was expected of type int. Okay, it's not going to match because adding a float and an integer, it's not allowed in OCaml. But yeah, my main point was to tell you that this is how you write it. And you for unit, because there's only one value here, you just specify it as an argument. Okay.
Okay.
Right. So if I go to, you see, like the way they have defined read into OPT. So you can actually see this. What have they done is they read the line and then they use this function which takes a string and returns an int option. Let's actually explore that. There is int of string. Can you tell me whether this function is a liar?
A liar in that it might no, well, it's not option, so it's like very strict. What do you mean by liar? Like it might not return an int?
By liar, I mean it might deviate from what it says. It's not really saying the whole truth. It's saying that you give it a string and then it gives you an integer. Is it possible that for any string you give, it gives you an integer?
No.
So is it a liar?
No, because yeah.
Yep. So I think you must have caught on the pattern now. There must be a more honest function for this. Can you guess the name of it?
Underscore opt. The same,
Yep.
but just
Perfect.
underscore
Perfect.
opt at the end.
And what is going to be the return type of this? I mean, what is the type of this?
Option. Like it's gonna be int option.
Perfect. Okay. All right, so let's see what happens. Like int of string, I supply it 4. What do you think is gonna be the value? Let me take
4.
a quick break.
4.
I'll be back in a minute.
Okay.
Hello. Um. Hey,
Yep,
I
I'm there.
see we have someone on the Discord chat. Yeah, I know I was on mute for a couple of minutes. I'm back now. Welcome to the stream. All right, so give me a couple more seconds. Right, where were we? All right, so you were saying something. What does it give me? Int of string of 4.
Some 4.
Really? what does it say? Int of string takes a string and it returns an integer, right?
Uh, no, it returns the option, the
Oh no,
one
but
below that, doesn't it?
no, but
Oh,
the
you're doing
before.
int of string. Oh, okay, my bad. Yeah, it's not gonna do sum for. It's just gonna return four.
Perfect. And what is it going to do in case of an empty string?
Probably crash because yeah, empty is
Perfect.
not a number.
Yeah, that's absolutely right. What about int of string opt? What is it going to return now for an empty string?
None.
Perfect.
Probably
And for 8, what's it gonna do?
sum eight.
Perfect. Okay. Yeah, now we have something called readline. Okay. This is going to take nothing but give you a string, right? It's just going to give out what was read. Whatever it is, 8 as a string, whatever you write, it's just going to output as a string, right? This is exactly what scanner.nextLine is doing, right? If you do next line, and if you look at the docs, it's pretty much the same. Like it takes nothing, but then it gives you back a string, right? And then you're able to assign it to input. Okay, so that's what it's doing, and this is exactly what we want, because at some point we want to compare it with we want to see if that is equal to Q, right?
Yeah.
And if it is for our function, can you tell me what are we going to do if it is Q? So here, yeah, we want to do this, right? We want to do read line. We want to do read line. Do you agree? Like let's say you let line equals read line. And I'm going to, for now, for this thing to keep quiet, I'll just do this. Okay. I'll explain in a bit. Yeah, so we want to read line. What are we going to do afterwards?
We want to see whether it's a.
Yeah.
Well, first we want to see if it's a Q.
Yeah. So how do you do that? Can you guess the syntax? We've been through this. Not if else really, but I think you know enough of the language to guess, right? How do you? Yeah, we want to check if
There was a
line is Q.
bool.
No, if line is Q, then what do we want to return?
In that case, we want to return none.
Perfect. Can you tell me, like, just go on and tell me how you would write it? I just want to write if line is equal to Q, then we want to return none.
Okay.
How? Yeah.
So then you can start by if parentheses line one equal sign
Great catch. Yeah.
parentheses or what you call it quotation mark
Yep.
Q. And then we want to assign it none, so it would
Yeah.
be...
So this is yeah. I wanted you to focus on this equals. This is perfect. And it just say none, but we also need to supply the else case. What are we going to in some what?
It's gonna be some int.
No.
Int.
No. What are we saying? We want to return. Okay, so you do you want to return an int option here?
If well, yeah, because if it's not a Q, I do.
What do you want to do?
Because here's the thing: is if it's Q, we shouldn't be returning anything anyways. We should just be breaking out at that point.
Yeah. So otherwise, if line is not equal to Q, what do you want to do?
I want to take that input that we just read
Yeah,
and I
so
want to
here's a cool
solve
thing.
it.
You see this? This is called a hole, and it's also another way of writing programs where you drive the development by looking at what the type system is expecting. You see, this typed hole should be replaced with an expression of type int option. Okay, so at this point, what do we have? We have a line, okay, which is a string. Now we want this line to be converted to an int option. Do we have a function that way which does that?
Does yeah,
What is
read
it?
int option.
No. We have a
Oh no,
string.
yeah.
We have a string, and we want to give this string and get back an int option. Do we have a function for
Oh
that?
yeah, read.
No. Okay,
Yeah.
so read. Okay, read int. Read int takes nothing, but we have a string.
Okay.
We've got
Right.
these int of things, right? Can you tell me which one goes there?
Int of string.
Yeah, int of string.
Int of, yeah.
All right, so
Oh, int of string option.
exactly. So int of string, we can do that. We can do int of string, and then what is the argument for this?
Sum.
No. Argument. Like, what do I need to supply to this function? It takes a string, right?
Yeah. Oh, line. You need to supply
Yes.
the line.
Yeah, supply the line. But then what's the problem? It says, oh, it returns an int, but an expression was expected of int option, right?
So use the other function, the int of string option function.
Yes, absolutely. Okay, the only thing is that you don't need this. I mean, it wouldn't have made a difference for the program, but you wouldn't need this, okay? Now, yeah, trick question. Is it going to work only on queues, or it's going to just exit on any bad input?
If line equals, it should only, hold on. So if line equals q, if that's true, then it's going to return none. Let's say if line equals z, that's going to evaluate to false, and then it's going to try to convert z into a number.
All right, that was a
No,
trick
it
question.
should only,
No, that was just a trick question. I have not used this function, so the behavior hasn't changed yet. You see, like, I've just defined this function, but I'm not using it in this pipeline. I'm using read into opt, which is like going to be the same behavior, right?
yeah, okay.
For Q. Anything works for it. Like anything is going to quit. But
Yeah.
yeah, if I do read, what's gonna happen?
Wait, you didn't give it the parentheses.
No, where? Where are the parentheses?
For read? Don't you have to give read a unit? Like it's expecting an argument, a unit or something?
No, because it's going to be, the unit is going to be supplied by this, right? See, like even read into OPT, like when I had read into OPT, it takes a unit. Am I supplying the unit? No, because it's going to be supplied by of dispenser. You see, it says, do you see that? Read into OPT
No,
takes a unit.
Yeah.
It just
But what you call it? You said that like, I thought sequence of dispenser was taking as an argument the thing that preceded it, which is read int option. Why are you saying now that read int option is taking sequence of dispenser? I thought you read it the other way. Whereas
no. I
remember
might
like
have.
whatever.
Sorry, I might have told you that. I didn't mean to say that read into OPT is going to take seek dot of dispenser. Seek dot, this is going to be supplied. You know what? Let me actually simplify this a little bit and do it this way. Like this. And even like I can delete this. Is this okay? What is this going to take? This is going to take a producer function where the function produces a box of A, right? An option of A. So we have that, and that is read int opt, correct?
Yep.
Now, our read, like I can also supply my read here. The behavior, to be honest, is not going to change that much. What's going to happen is if I enter any argument which is not Q, right? If I enter a string like A, what's going to happen is that it's going to go to this else branch, right?
Yeah.
And then let's say the line is A. Okay, I entered A. So is it Q? No. So it's going to do int of string opt of A. What is int of string of opt? Int of string opt A. What is going to be the value of this?
None.
Yes. So even in this case, it's going to return a none, right? We're going to exit the loop.
Okay.
So what are we going to do is we'll return a string every time. Okay, we'll return a string of options. Sorry. Yeah, we'll return a string option. So only in case of Q, I will not produce a value. In any other case, I will always produce a value. So this is going to be just line. Okay. Can it be a line? Can you decode this error and tell me what's gonna happen?
String. Okay, so it says expression has type string, but an expression was expected of type string option. Yeah, it's saying that a data type mismatch.
Yeah, so how do you make you have a string, how do you make it a string option? Do you remember how to construct an option?
It's not. No, I don't. Was it parentheses? No, I don't.
Do you remember how many constructors there are for an option? There are two ways to. Sorry, I already said it. There are two ways to construct an option, right? Can you remember the two ways?
Oh, yeah, I do actually. Yeah, some and none.
Yes. So you have a line. How do you make it into an option?
Put some in. Well,
Yes. Don't hesitate. It's absolutely right. Right? How do you construct an int option? You do sum for. How do you construct a string option? You do sum any string. There you go. You got it, right? Okay, thing compiles. Almost. This function is fine. What is this function doing? This is not really converting. This is not doing the conversion just yet. Okay? This is just saying, I know how to produce a box of string. I'll only give you an empty box when the entered value is
anything other than Q.
no, an empty box when it is Q. I'll give you.
I'll get you an empty box when it. Oh yeah, okay, because it's the then none, and then if it isn't Q, then I'll give you a box with some. I got
whatever that was entered, right? I give you a box filled with whatever is entered, unless it is Q.
Right. Yep.
Right. Okay. So can we? I mean, are you okay for me to just convert this back to this nicer pipeline?
Yeah.
Okay. So it's going to complain now. Can you understand this?
This expression has type string sequence equals unit string sequence node, but an expression was expected of type int sequence. Okay, so let me just compare the two. And it says sequence node type string is not compatible with type int. Okay, so there's definitely data type mismatch, but why? Let's see. So read is returning.
Just concentrate on this part. It's able to dig down deeper. I mean, you have a more complex type signature here, but the type system is actually simplifying it and then telling you that this is the mismatch. Okay?
Oh, okay.
Yeah. Can you go on from here?
The type string is not compatible. All right, type string is not compatible with type int. Type string is not compatible with type int. So if it's
All right, let's actually.
no, I'm not.
That's fine. That's fine. What is this? So, in our case, what is tick A?
Int.
Is it
No. Hold on. Option. No. It starts out as string. It's string.
exactly?
It starts out as
Exactly.
string and then only if it meets the criteria. Okay, yeah.
Yeah, but there is no way. I mean, what is fold left expecting? Fold left is expecting a sequence of what? In our case, I gave it a plus. So plus means that plus is the operator, right? So this has to be an int. This has to be an int. What is tk? Tk is an integer, and what that makes our sequence to be of integers, right? Um, by the way, hey Tragic Armac, I did not see your chat there. Oh man, I sorry. I just had a burst of messages. I wasn't getting your messages earlier. Now I see all of your messages at once, which is ridiculous. But thank you for responding. Welcome to the chat. I'm sorry. Welcome to the stream. Also, Kazimir, OCaml is beautiful. Yes, it's absolutely beautiful. Yeah. So sorry for interrupting you there. So yeah, fold left. Where was I? So yeah, we supplied plus and we supplied 0, which makes we supplied plus, which means it already knows that this has to be ACC has to be an int, A has to be an int, and it also produces an int. So obviously this fits in place. Now it also expects this ACC to be an int. I've supplied a 0, which checks out. But what do I have when I give of dispenser function? My function, which is read, is producing a string option. So of dispenser will produce a sequence of strings, which is not going to sit well with the fold that I have in place. Does that make sense to you?
Yep.
And that is exactly why it's saying string is not compatible with int, because it was expecting the thing to be an integer, right? When it's folding. So again, we were able to deduce ourselves that we want this a to be an integer, but we have a string here. You see? And that is
Yeah.
and that is the mismatch. And the compiler was able to do it entirely and tell you exactly where the type mismatch is happening, right? It didn't stop right here. It said, okay, string is not compatible with type in. Okay, what do we want to do? Like, I just want you to explore. What do you think should happen now? So we've got a string. We've got this, right? We've got string seek.t. What do you want to do next? Like, but we want int seek.t, correct?
Yeah.
Uh,
So we should convert the strings to ints if they're convertible. Oh, and then we had one you showed me earlier. It was like I forgot the function name, but basically it takes a string as an input, and if it can convert it to a number, it does that.
yes.
I think it was like read or
Int
something
of string.
int of string. Okay.
Right? Int of string knows how to convert string to integers. Okay.
Yeah.
And there is an interesting function. Okay, so here's the thing. So what do we have? We've got a string sequence.t. Hello, Mateus Mello. Welcome to the stream. Yeah, string seek.t. We've got this string seek.t, and we have a function that takes a string and gives an int, right? Let me actually write it here. We've got a string seek.t, and then we have a function that can go from strings to ints, right? And then what we want, so we can say like our goal is to get int seek.t, correct?
Yeah.
Now, if only there was a way to apply this function to each of the strings in this sequence, we would get it, right? We would get an int seek.t. Do you agree?
Yeah.
What are we looking for is a function that goes from string seek.t to what?
Int seek.t.
Exactly, right? And there is a function for it. Can you guess the name of it? You might be familiar with it. It's again in strings. We can go through the autocompletes, and you can tell me. We got equal, exists, filter, filter map, find map, flat map, full left. What do you think is the function we are looking for?
Something to do with strings. Okay.
Anybody in chat knows about this?
Up dispenser. Maybe
Yeah, so
node or up dispenser.
okay.
I only say that because,
Yes, what was your reasoning?
just because you were going back and forth between the two, so I don't know if that's like a little hint.
Yeah, I actually did an oopsie and then I recovered from it. I actually gave you a hint. Well, anyway, so you understand that we are looking for a function that takes a string sequence and gives an int sequence. Does the syntax and the goal, everything make sense?
Yeah.
Okay. We've got map. Okay. Look at this. This is generic over two things now, A and B. And what is A in our case?
String, and then B would be int.
Yes. The first parameter for this function is another function. And this is where you talk about, I should have talked about it a little earlier, but yeah, this is where we are talking about higher order functions, like passing a function to another function. That's what we've been doing so far, right? I passed this read, which is a function, to of dispenser. And I passed this plus, which is a function, to full left. And even earlier, printf.printf, like whatever, that was a function that was taking an int and producing the side effect of printing it to the screen with a new line. And that was a function that we were passing to iter. And printint was all function that was being passed to iter, right? Higher order functions, functions as values. Yeah, I just wanted to make it clear at this point because I had forgotten to do it earlier. Right, so seek.map, it takes a function that goes from A to B. It doesn't matter what it is. It just goes from A to B. Okay? Yeah, and then it takes a sequence of A's, gives you back a sequence of B's. Isn't it obvious what it's going to do?
It's going to convert the strings to numbers.
Yeah. I mean, talking generally, it should be obvious. I mean, it will, if not now, it will eventually be obvious that this is going to take a function that knows how to convert A's to B's. Okay? And then you have a sequence of A's, and it's going to supply each of those A's to the function, and then going to get back the B, and it's going to construct a new sequence from those new values. You see what's happening?
Yeah, sequence of map should probably take read of int of string.
Yes, that's absolutely right. I just want to hit home the fact that it is doing the transformation, right? Each of the element of this sequence is going to be supplied to this function, and each of the output of the function is going to be a part of the new sequence that you get back. Is that clear?
Yeah.
Okay.
So basically, this function, it's going to be applied to every element of sequence A to convert it to sequence B, of type B, and put it in a new sequence.
Yes. You've got a sequence of A's. Each A is going to be supplied to function, because function doesn't take a sequence, function takes an A. So you have a way of getting values from a sequence. You don't really know how it does that. you just seek.map internally knows how to pull values out of a sequence. Okay, it's going to pull each value from a sequence, and it's going to give each of those values to the function that we pass, because that was a contract. You have to give me a function that takes the A and gives a B, right? So you do that, then what I'm going to do is pull each value in the sequence that you give me, supply to the function that you gave me, and then construct a new sequence of all the values that were produced for each element that I passed to your function. Okay. Hey, Abstract Pepe. Yes, I will keep the recording for later. Yeah, so that should be clear. Okay, let's do it. We have at this point is where we have the problem. So what do you want to supply this to? What do we want here?
Map.
Yeah, it's gonna be seek.map. And what should be the function?
Read.
Sorry? Read is a function, is already here, right?
Okay. So what is read int of string.
Hey, we've got this, right? We've got this. But not yet. We'll see. Can you guess what's gonna happen though? It's compiling, so it means I can run it.
Maybe we should do int of string option.
Good point.
But okay.
Let's go. Step by step.
Yeah. Let's okay, so it's running.
Yeah, it's running. What do you want me to type?
1, 2, 3, and then do Q. I just want to see if it does normal behavior first. Okay, normal.
Okay.
Could we run it again? Could you do 1, 2, A?
Boom.
Exception failure. Int of string. So it crashed.
Yeah. So it wasn't able to convert this. So what happened was it was not Q. Sorry. Yeah. So it was actually failed here. So what happened was that if it is not Q, it was just entering those lines. So at this point, we have string seek.t, correct? At this point, we'll have int seek.t.
Yep.
Right? But the thing is, this can fail. Like internally, map is doing the conversion, right? It's pulling these strings out of this sequence, supplying it to int of string, and then constructing a new sequence of integers that are resulted from this conversion, right? But this conversion can fail, which is exactly what happened. Why didn't it happen in case of Q? Because in case of Q, we said, hey, read said, I don't have anything to produce now. It's not even going to go to map. It didn't even go to map.
Yeah, we accounted for Q.
Yes. So in case of Q, it's like we're exiting early. You know, it is exactly like you're doing here by doing a break, but the way you do it is more declarative, where you're not actually using the concept of a break and a loop and whatever, right? You're not doing that. You're a little bit direct to what you want and what you have. Okay. I'm just reading from the chat because A or any other letter is not known for the logic we implemented. Yes, that's right. Yeah, so we accounted for it. Wait, let me close this. Okay, so this conversion fails, and it exactly failed at this point, right? Conversion failed at this point, and then we exited. The thing we did was like we didn't even print the sum so far. Right, we exited early. I mean, it was not graceful. It crashed. The program crashed, and that you can see here. Right, the fish on the left is red, which means it failed with a non-zero error code. Right, okay. You can see in case of Q, the fish is still green. Okay, yeah. What do we want here? we want you said that we could use int of string opt. I can do that, but can you tell me in that case what would be the type we're going to end up with?
String option.
Okay, so we've got string sequences, and we've got a function that takes a string and returns int option, right? What is going to be the type of the sequence?
The type of the sequence is going to be int option.
Can you write it out? I mean, can you tell me like how would it look like?
Yeah, just like that, but then option after int.
Like this?
Like that. Yeah.
Perfect.
Oh, okay. Okay.
No,
I don't know
that's
where the backtick
absolutely
is.
no. That is absolutely correct, and it's going to fail here, and you should be able to reason why that's going to fail.
Incompatible. Int, yeah. Oh, because the plus is expecting exactly because the plus wants ints on both sides, and we're not doing that. We're supplying an option on the left-hand side of the plus.
Exactly. So uh, we've got we've got we've got int option sequence of int options, correct?
Yeah.
But we actually want what? What kind of sequence do we want?
Int.
Yes. Now there is this function called filter. Okay, so before we actually look at the function, I want you to logically think what do we want to do? Like we have so we're getting a sequence of strings, right? And logically, what do we want to do with those strings? Can you
We
just
want to
walk me through?
check if that string can be converted to a number or not.
Yeah. If it is not convertible, what do we want to do?
I think in the program we could just display whatever they typed and say is not a number.
Yeah, we'll get to the display bit a little later. The minimum thing we can do,
Oh,
like what?
oh, okay, I get what you're saying. Well, we don't want to crash the program if we don't get it. We just want to handle it gracefully.
Yeah, yeah. So we could skip it, right? So
Yeah,
in case of map, what it's doing is it's converting every string. It's converting every string to an integer. Like before, it was let's actually do this. So what map does is semantically, it's going to operate on every. I mean, it's going to try to apply the function that you pass to every element in the sequence. Okay.
yeah, yeah. So we need to filter first. We
Exactly.
can't pass. There's no guarantee that we need to basically filter first the value so we're assured that whatever we're passing map has already been like vetted or it's already been checked.
Absolutely. Right. So we can do it this way, right? Let's say, okay. So now we want a function. Now we want a function that right now our goal is. Can you tell me what our goal is?
To determine whether the
No, no,
string
no,
that
no,
we have
no. So we've got an int option seek.t. What do we want actually?
int.
Yeah. So can you
Well,
write?
int that's
Yeah. So can we write it down?
yeah, int.
So what do we
We
have so
want
far?
our goal is to convert int option seek.t to int seek.t.
Is this right?
Yeah.
Perfect. Okay. Yeah, this is one goal. Um, uh, can, right. So we can do this. We can of course do this. Um, let's actually go via a detour. Okay. So we've got int option seek.t. we want int option seek.t, but the only thing we want, I mean, what we want to do in this one, right, is we want to remove all the options which are empty.
Empty?
Yeah, I mean, so what is option? Option can be in two states, right? Either it could have something or
Oh,
it could have nothing. So what I'm saying is
oh,
like,
okay.
let's actually work through this with an intermediate goal where
Yeah.
we want we want to convert this. We're not really changing the type, but we are removing certain elements from the sequence. Okay,
So this
and
is where the actual filtering comes. I get
exactly,
what's going on. This is
yes,
basically where we determine that, like, okay, is it a number or not? Can it be turned
yes,
in? Because the thing is, the int option, at that point, we already assume, like, okay, you're definitely a number. So the actual filtering will happen the step before. And that's why, so if it's good, it'll be some. If it's not, then it could be none.
yeah.
If
So
it is a number,
filter. We want filter, and we only want to keep those values which are what
some, like
exactly.
actual numbers.
Yes. So if you look at excuse me. So if you look at filter, it takes a function. Just let me know. Can you read this? Can you understand what's going on
It
here?
takes it takes a function, and that function takes any data type and it returns a Boolean.
Okay.
So maybe it's basically saying like the data type that you supplied, are
Mm.
you the oh you remember actually never mind. Yeah, maybe it's taking the data type that you supplied and it's asking, are you the same type of data that um how do I put it? Basically it's basically saying like, okay, I gave you an int. Are you an int?
Yeah, that's right.
Oh, and then it
Kind of right.
returns the second one is a sequence and it returns a sequence.
So
Okay, yeah, so this looks like this.
what are the arguments to this function?
In our case, the arguments,
No, no,
let's
no. I'm
see.
just
So what
asking in
function?
general, like seek.filter, seek.filter.
Yeah.
What are the arguments to this function, and what is the return value?
Arguments are one function, one sequence, and a return value is one sequence.
Yeah, and you already have an
All of the
understanding of
same
what
data
filter
type.
does. Yeah, yeah. You
Uh-huh.
already and in our case, in our goal, like our latest goal, um, can you tell me?
Oh,
Yes.
my bad. I'm starting to okay, so like that filter function, it takes one function and one sequence. So the sequence we'll be passing it will be the string options or okay, we're gonna be passing it a list or a sequence that we want to filter on. I'm guessing
Yes.
that function is going to be the thing that allows us to filter on it. And once we're done filtering, it's only going to return a sequence of the things we want filtered.
Yes, that's right. That's right. So in our goal, can you tell me what is tick A?
In our goal, it's going to be, well, we want int option. It's going to be int.
No,
Uh,
in this case, we want to turn this, right? We want to turn int option seek.t to int option
oh, it's going to be int
seek.t.
option. Yeah,
Exactly.
it's going to be
Exactly, right?
option.
So, and
Summary.
what do you think, when do you think it should return? Yeah, can you think of the function? I mean, what should the function do in our case? We've got a sequence of int options, and seek.filter is expecting a function that takes an int option. So you agree that tick A is int option, right? So now
Yeah.
our goal for our function to be passed to filter is what? It should go from what? Int option to what?
To int option.
No,
Oh, it's a sequence.
no, no.
Uh,
The function that I'm talking about, this first character, first argument. What should our function be look like? What should our function
oh,
look
my
like?
bad. I got you. Int option to bool.
Yes, you understand it, right? Like we already have int
Yeah.
option seek dot t, and
Yeah.
we want to again get the same int option seek dot t, just that the empty ones should be removed from the sequence. And
Yeah.
when we got this tick a as int option, so what should our function be? It's just answering this. I mean, substitute tick a to int option, you get the signature of the function, right? You want a function that goes from int option to bool,
Yeah.
correct? Now,
Yep.
when should it return true?
If it's an actual number, if it can be converted to a number.
Yeah, and in the understanding of option, when is it true?
Some.
Yes. So if the option is sum, then it should be true, right?
Yeah.
And it's so what did I say? I said like if the option is sum, then it should be true. So there is actually a function option dot is sum. Okay, look at this option dot is sum, and this is the exact. This satisfies the function we wanted, right?
Oh. Yeah.
We wanted tick a to bool. It just happens to be the tick a option, right? It doesn't really care. Tick a and tick a here are different, but tick a can be anything. It could be tick a option, option, or it could be list, right? Only thing that matters for filter is that whatever function you pass should be able to take the value of type of the element in the sequence. Okay.
Yeah.
Now, at this point, what is the type we're having? What is the type of sequence after we're filtering out? What is this type?
It's still gonna be an option. It's gonna be an int option.
Int option
Some.
seek.t, correct?
Yeah.
It's okay. So let's just work through this. Option dot is sum, and then I'll give it a value sum for. What's it going to be?
It's gonna be a sequence of sum four.
No, no, no. There is no sequence here.
Oh, my bad. Okay. Oh yeah, you're right. It's just gonna be bool. So it's gonna return true.
Perfect, right? And then when I do uh, option dot is sum of none, what's it gonna be? It's gonna be false, right?
False.
And can you just tell me like what filter is going to do? Explain like what it's going to do.
Filter is going to um throw away nuns and keep some and put it into the sequence and return that to us.
Yes, pretty much. To be more generic about it, uh, functions of this form are called predicates, right? Functions that take any value and return a boolean is a predicate. Okay.
Hmm.
It's going to take a predicate. It's going to take a sequence, and it's going to give you a new sequence back with only those elements for which the predicate reported true, for which the
Yeah.
predicate was satisfied. Does that
Yep.
make sense?
Yeah, it
Yeah.
does.
So I can. Yeah, I'll just do a simple example. I've got how many? Let's say we'll take 10 integers, right? I'll do seek dot int, and then I'll start from 0. Okay, and I'll do a seek dot filter, and we want to supply a we want to supply a function. By the way, you can do anonymous functions, right? We want to supply a function that takes a number and it returns a boolean, right? I can say n mod 2 equals 0, and then I can just do list dot of seek. Can you guess what this does though?
It returns even. Let's see. So nmod2 tells you if it's even because you're
Yeah,
asking if it's equal to zero. If it is equal to zero, that means the number's even.
yeah,
And yeah, so it's just returning all even numbers.
Yeah, and then at the end, like I just called
Let's see
another
this.
function, which is converting a sequence to list.
Uh-huh.
Oops. Ah, all right. Sorry, I didn't mean to do that. This. Oh. Ah. Okay. So, oh man, it's the same problem earlier. Like it's an infinite sequence. It's never going to end. You see what I mean? Like it's going to just hog your memory, and it's going to keep converting. Right. It's going to start from there. Yeah. So let me. Right. So it's going to be 0. We start from 0, and then we filter, and then we only take 10 numbers. Okay. We'll worry about what these things are doing, but this should be readable enough, right? We have an infinite sequence of integers starting from 0, and then we're filtering out all the odd numbers, right? Meaning we're dropping the odd ones and we're only keeping the even ones. And then of those infinite sequence, I only take 10 of them, and then I convert it to a list. Okay. And there you go. You got it, right?
Yeah.
Filter is only going to keep those elements for which the predicate says true. Okay.
Yeah.
You have a filter on list itself. Like we don't need to go through sequences. I can just do this filter, and let me just do option.isSum, and then let me create a list. Okay, let's create sum 1, a none, and sum 4. Okay, at the list, can you tell me like what the list is going to how the list is going to look like?
It's gonna be it's gonna be 1 and 4. Some 1 and 4, because those are the only ones that are gonna return true.
Yeah.
The
I
little
need
ones
you to
don't.
be precise. Is it going to be 1 and 4?
Uh, mm, I'm trying to think if it's gonna have the word sum in front of it. Let me see if it's a option. No, it's gonna be just 1 and 4
Are you sure?
output. List filter option is someone,
Yeah.
option
Okay,
is some. Yeah.
tell me the type of the list.
The type of the list, int.
Is it int list? What is the type of each element in the list?
Oh, option. Yeah, it is option. It's
Yeah.
int option.
Yeah, it's the type of list is int option list. Do you agree?
Yeah.
And what
So it's gonna be someone, someone.
what? Sorry?
No, go ahead. What?
You were saying the output is going to be something. What did you say?
Someone, some for.
Absolutely right. What you need to understand is filter is not going to change the element type, right? It's not.
Yeah.
It's whatever type of list you gave it. It's going to just give you this same type of list, just that some elements may not exist in the newer one. That's it. It's never going to
Determined
add
by the
something.
predicate.
Yeah, exactly. It's never going to add an item to the list. It just
Yeah.
in some cases, right, might drop some elements. Okay.
Yeah.
Yeah. Okay, that's cool. Now, if you have someone, I mean, if you if you have a box where you know for sure that it's going to have a value, right? You can get that value out. Okay. Our goal, right? Our goal is eventually that we now are here. We now have a way to filter out all the empty boxes. After this point, we know that all our boxes are going to be full of an integer, right? They are going to contain an integer. Is that clear to you?
Yeah. Yeah, because they were properly
Now,
filtered. Yeah.
yeah. Now we just need to convert those int option seek.t to int seek.t, right?
Yeah.
So let's actually write it down. So we've got Now, can you tell me like what function are we going to do? Like we want what is now our goal? Our goal of f. Like what should happen? Like do you have an idea of how to go about this?
How to take an option to an int? Mm.
Yeah, okay, so you already
How to
figured it
take an
out. No,
int
you
option.
you were already a step ahead. So basically we now want this function, but I wanted you to answer what function are you going to use on the sequences? What function are you going to use? Is it going to be filter? We want to transform into option seek
No.
to, yeah. What is it going to be?
Well, I know a filter doesn't change the data type. What you put in is what you get back. Maybe, what about map?
Yeah. So let's go ahead and do that. Let's do seek.map, and I'll put an underscore. Look at this. It tells you what you need to put in there. You just need to put an expression that takes an int option and it gives you an integer. Right? That's exactly what we want. So I hope we're clear. Like how did um, we're clear about the entire journey and there are no gaps in the middle. Like we started where we were starting with strings, and then we
Yep.
converted strings to ints, but that was not okay because we were crashing. And then we converted to option. The problem there is we cannot use addition with options, right? So what we did was we decided, okay, so we've got the sequence of int options. Let's actually remove all those options which are empty. Okay, so we did a filter. Now we've got we've still got options, but we know at this point we know that all of them are going to be filled boxes, right? None of them is going to be empty because they're going to be dropped at this level, filter level, correct?
Yeah. Hmm.
Okay, so now the only thing, this very clearly says what you want, right? You write it this way, and you put an underscore in there, and it's going to tell you the expression you want to fill in that place, right? You need a function that goes from int option to int, and we have exactly that. What do we want? We want to get the item inside the box out, right?
Uh-huh.
There is a function for it, option.get, right? It takes a box.
Oh,
and
nice. Yeah.
yeah,
Takes
so
away the option. Just
yeah,
gives you the.
yeah. What should it be here?
What was the name of the function? Can you repeat? Can you go back to it again? Uh, get. Okay, so it's gonna be option.get.
Is it going to work?
Um,
It compiles,
we
but is it going to work?
we we pass it. So let's see. Filter. We just finished filtering. Well, if we filtered properly, it should because we're passing it boxes that do contain numbers.
All right, let's actually give it a test run. Give me
Yeah.
inputs.
Uh, 1, 2.
Wait, 1, 2.
Or 1 enter and then yeah, and then do Q. No, actually don't do Q. Do A. Do 3 and then do Q. 1, 2, 3. Okay, so it did sum it and it ignored A and it didn't
Yes.
crash. So that looks good.
Yeah, it looks good because it worked. It is working as expected, right? What's going to happen? Of dispenser is going to keep calling this function until this function says, I do not have a value. How does it say it doesn't have a value? By returning a none. When does it return a none? When the line is equal to Q, right?
Yep.
And this thing is going to try to convert the input, the line into a string, into an integer, and this might fail in certain cases. In which case, it just returns a none, right? At this point, we have an int option seek.t. We've got a sequence of int options, and here we filter out all those let's actually take this, run this through. Like, you need to understand that this is going to be executed like line by line. Uh, you know, to again put it naively, it's going to be executing line by line. First, it reads. Okay, let's go with one. What happens? It reads one, and at this point, what is the value do we have? What is the value we have? Can you tell me that example value?
1.
Yeah, one as a string, right?
Oh,
One as a string.
yep.
Yeah. So let's actually make let's do a vertical split and example run. Okay. So we read one, and tell me like what is at this line. At this line, what do we have? The value.
So we read in 1, and the first question that gets asked, is it equal to Q? No. So then it goes to sum. Oh,
Mm-hmm.
okay. Sequence of dispenser. It gives us a sequence of 1. So
Mm-hmm.
the element 1 is in there. Then it jumps down to map, int of
No.
string,
So
and it asks,
at this point, we have. Do you agree? Like we have this string. Okay.
yeah.
And then okay, so
Mhm.
and then what happens is for that one in the sequence, we're going to apply this function. So after this, what do we have?
Okay, so the next thing that happens is int of string, it asks this question, int option 1, it turns it into an option. It's going to be sum 1.
Like this?
Yeah,
Are you sure?
because it's still, no, would get rid of the, what you call it, a quotation marks.
Yeah. Perfect. Okay. So we've got why, because it's going to give an int option, right? All right. So
Yeah,
what's going to happen? What happens to this sum one
it
at this
goes to the
stage?
filter and it passes the filter. The predicate returns true.
So what are
So
we
it
left
stays
with?
in the list.
So we're
Same
left
thing,
with sum
someone.
one, right? Okay.
Still,
And
yeah.
then what?
And
This one.
then right here we check, and we verify. We go from sum 1 to just 1
Yeah. There's
because
no
it's no longer
verification at this
option.
point. There is no verification at this point. It just gets the value. Okay.
Uh-huh.
Yeah. Repeated question. Do you think option.get is a liar?
Uh, can you pass it? No.
I would like you to rethink.
Oh, hold on. So no filtering.
No,
Yeah, okay,
just
so
forget
let's say,
everything. Forget everything that is around it. Just think about a box, right? Let's say first let's create a box. Okay, you create a box. You create an option.
okay. So oh, okay. Create an
Yeah,
option.
yeah. You can give it a name.
Sum
You can give it a name.
x
Okay.
equals
Mm-hmm.
sum 3.
Okay. Right. Now, when you do option.get x, what are you going to do? Well, I mean, what are you going to get?
3.
Perfect. Okay. Construct another option.
Okay, so same thing, but instead of 3, we could do s
S as character or string?
string.
Okay. What is this going to give us?
Double quotes. Double quotation s.
Perfect. Yeah. So can you think of when? Yeah. Did you change your mind, or you're still saying that option.get is not a liar?
I didn't change my mind. I don't think it is a liar.
What is it saying? What is a contract?
It's that if you give me an Oh wait, hold on. Okay, so if you give me an option, I'll guarantee you to give you that data type. Now let's think, is there a situation where that could not be true? Um, you give me an option. So some, okay, so let's look at the filtering one because it's probably that's where it'll come into. So okay, oh wait. So the question we ask is if it's some quotation mark S and then it takes that away and it just gives us S and I don't know. I can't think of a situation where it's lying.
Okay, so how many constructors, in how many ways can you construct an option?
Two.
And what is the other way?
None.
What if you give none to option.get?
Uh, I don't know. Well, I'm guessing it's not good.
It
Would it
isn't.
just be let's see what it does.
No, you take a guess. What will it do? It's
Um,
saying that you give it a box of A and it will open the box and give you the A
oh, it'll
inside it, right?
crash. Yeah,
Exactly.
it'll crash because there's no A to pull out of the box.
Exactly. You see how it's a liar?
Okay. Yeah.
Yep.
Yeah.
So yeah, just wanted you to be aware of it. In our case though, it is safe because we're never going to run
We
into a
already filtered
situation
on it.
where it's going to be a none, right? Because we are already filtering it out. Okay?
Exactly. Yeah.
It is all fine. Okay? But there's a better way to do it. And that is you just do, instead of all of this, right? You just do filter. Okay, so before I do that, is this pipeline good for you? Like, are you able to understand how this is working?
Yeah.
Okay? Yeah, so what are we doing? Like, we're doing like map, filter, and map. Like, this is all unnecessary. I can just do filter map, and boom, it's the same behavior. Let me show you, like, 1, 2, A, 3, Q, boom. Okay, so what's the deal with filter map? Look at this. Filter map takes two things. A function, it's a predicate but more powerful. What is a predicate? It takes an element and it just says true or false. Okay, but this function is also going to transform. Like, it's like a transformation predicate, along with saying. So there. How do I put this? So option has two constructors, right? Either something or nothing. Okay, so we can pass to filter map a function that transforms values of A, but that transformation can fail. Okay, when that fails, filter is going to skip it, right? It's not going to put that element inside.
Uh-huh.
Is that clear to you? Look at how nice this is. So you give it a function that can take an A, but it gives you a B option. You see, in case of predicate, you had no way of expressing transformation. You'd have to do that manually. Like, look at the state of this. You first map it, you filter it, and then you get the thing back, right? You map and then you filter and then you get it back. But because we already have like a more intelligent, a more suitable function called filter map, which gives you an opportunity of doing two things at the same time. One is transformation. Two is dropping the failed transformations. Okay, so
Yeah.
in our case, what is A
String.
and what is B,
Int.
right? And why does it fit in place? Because int of string OPT is of the exact shape, right? A to B option, where A happens to be string and B happens to be int. And look at what filter map is doing. Takes a function that goes from string to int option, takes a string sequence, gives you an int sequence. Right?
Yeah. It's
And
yep.
it's just in one go, you do all the things. You do filtering, you do transformation. Right? This was made possible because we already had a way to convert to safely convert safely convert strings to integers, right? By means of this int of string opt function, we were able to do that, right? And we just had to fit it in place. And now we get this functionality where if the transformation fails, it's just going to skip putting that element into the sequence. Okay. So what's going to happen? We are here. Okay, we have read 1, and then int of string opt says sum 1. Oh, it's going to put it in the sequence, right? We're already here. And then it's going to be, doing 0 plus 1, and then it's going to call the read again. Okay, let's do a read. Let's do a read, and what it's going to do? It's going to be sum 2, and it's going to be putting the element 2 in the sequence, and what it's going to do is 0 plus 1 plus 2. Okay, why is it doing, like you can see fold is doing that, right? And then in the next case we get A, right? We get A, and what's the return value of int of string opt of A?
Sum A. No, sorry, it's gonna be none.
Exactly, because you cannot convert A to a number, right?
Yeah.
So it's gonna be a none.
Yep.
What's gonna happen is like it's not even going to put it into the sequence. So this fold, it's not gonna come here, right? It immediately starts reading the next one. So we get a 3. I mean, we enter a 3. It's gonna be sum 3, and it's gonna be sum 3. Yeah, 3 is gonna be put 3 is gonna be put here, and it's gonna be 0 plus 1 plus 2 plus 3. And when we here's the thing, when we enter Q, what's gonna happen? Like, it's not even going to come to filter map. You see why? Because we already returned none here.
Yeah.
And then it's just going to give us an integer, and the value that we have in this, right? This is 0 plus 1 plus 2 plus 3, which is 6, right? This is going to be 6, and this 6 is going to be supplied to what? This function, right? If I just end up where is it? Yeah, if I just end up copying this thing and putting it here, right? What is it? It is just a function that takes an integer and prints it to the screen, which is sum colon this, right? Okay. Yeah, that's it. So you're getting this, right? This is fine. And any questions so far?
No, I got it.
Okay, so we've got minor things to do, which is, I don't know why my display keeps turning off. Right, so we want to replicate this, right? Number 1, number 2, number A. Okay, so let's actually, before reading the line, let's just do print string, and it's gonna be number. Okay, and let's actually exit this and exit this. Okay, we print the number in, and now it's time to run these two things together. What do you say?
Yeah.
Java sum stream. Of course, it's not exactly the same, but we'll see what we we'll see where the gaps are. So it's going to be OCaml total.ml, right? And then I'm going to enter. Okay, so that looks fine. Number. And then it's going to be 1 and 2 and A. Okay, the only difference is I do not print that A is not a number. And 3 and Q. All right, that's the only difference. All right, so I just want to ask you, like, are you tired now, or we should just go one step further and also get that thing in?
How much longer would that take?
It shouldn't take more than 10 minutes.
Yeah, let's do it then.
Okay.
Why not? Let's.
All right. So far, are you clear? Like, I think it would have been a pretty big journey for you coming from Java to something like OCaml. They're very different paradigms. All right. Yeah. So one last thing, and then after that, I'll at the end I'll just summarize the differences, and we can go over other questions if there are. Right.
Yep.
Hey, Mohammed Awais, you're almost. I mean, we're almost at the end of the stream, but I still appreciate you joining it. Okay, so what we want ideally is to keep these states that are in, right? There is something called a scan. Okay, so I'll not go into details. So there is a scan, right, which is like full left. Scan. And it takes two things. Scan and gives you, let us yeah, it's similar to fold left, as you can see, but the thing is, fold left, you see this fold left is going to give you an accumulator at the end, but a scan is going to give you a sequence. So let's actually see what this is doing. Because we have a sequence, let's see sequence. Let's do this. Let's sequence dot iter. Let's do a print. Yeah, there's gonna be printf dot printf, and it's gonna be %d/n. Right. If I have this, and then you see, it started with a 0, and then I do 1, and then I do 2, 4, Q. One more time, 1, 2, A. You see, it didn't do anything because it was exited. I mean, it didn't even come to the scan because it was filtered out, right? And then 3, and then Q. You see, like, it printed it printed the intermediary values, right? Okay, so I think I went on the wrong path. Maybe we want to keep the fold in here. Well, sorry about that. So we ideally so more differences. So we can do something like this. If it is Q, then we do not have anything to produce. If it is something else, then we would like to what do we want to do here? We want, if it is a none, let's say we keep this and yeah, there's no clean way of doing it, but I can AJ filter map int of string opt. How do we, if I just do a map here, we've got All right, so I can just do let inputs equals this in inputs. Okay, so I can do this one is gonna be, I want to iterate over these. Okay, so first thing is like I am going through these, right? I'm going through these and printing printing something that is not a number. So the thing goes like printf.printf percent s is not a number. That's what you say, right? And then a new line, and then I do this. Okay, so it's going to say, oh. The thing is, if I, it's already an integer at this point. Oh, no. Okay, so let me, right, so what is this? We have an option. So we do this. This is another concept which I do not have time to explain. So match opt with if it is something, right? Or no. If this is none, that's when you do. If this is none, then what do we do? If this is done, then we print. Then we do a printf.printf. Percent s is not a number. That's what we do, right? And then a new line.
Yep.
Okay. So, but why is it complaining? This typed whole. All right. So in this one, if and then inputs, I can do seek.filter map of id fun.id. All right, so what does it say? This expression takes a string and returns a unit, but an expression was expected of type unit. So yeah, yeah, so this okay, AR, I have to do the match opt with none. You do this. Oh, at this point we don't even have a string. This was a bad idea. Do you want me to do you want me to still push through or actually conclude the session? I can. How much more it's going to take? It's going to probably take 3 more minutes.
Sure, go for it, man.
All right. So we want to actually not.
Yeah, I don't mind watching. Yeah, I don't mind watching Ucode. I'm pretty much out of gas, but I don't mind watching Ucode.
Oh. Yeah. Int of string opt will actually eliminate, like at this point, if we do this, right, when it cannot convert, it doesn't preserve the string that it was, right? So for example, if I have to go here and then int of string opt of something that's not convertible, we just lose this information, right? So at this point, we can use the result operator that we discussed earlier, right? It's not necessary that you understand all of this, but of course, if you want to ask questions, you can. So I'm going to do my custom convert function, where it's going to take line, and it's going to do this match line. Match int of string opt of line. Right? If it is some number, then it's going to be okay it's going to be okay to convert. If it is none, then it's going to be error of line. It's just going to preserve that, right? Okay, so width. All right, so in this one, what I'm going to do is I'm going to map it with convert, right? And here it's going to be, yeah, so if let error s equals opt, no, it's r, and it's going to be r, then this syntax error, oh my god. Yeah, let's actually, all right, so let me do this. I can do pretty much function. Yeah, it's not going to be none. If it's going to be, if it's going to be what? If it's going to be error s in any other case, it's not going to do anything, right? And in this case, it's going to print s. Okay, and here it's going to be filter map and option result. There is a way to convert result.to option. Yeah, so result.to option. Okay, hope this, okay, this would work out. And find this. All right. Are you ready to compare the behavior?
Yep. Let's see.
Okay. Okay, so on the left side we have the OCaml, on the right side we have the Java. Okay, they're both asking for numbers. Let's go 4, 3, and A. A is not a number. Okay, nice. And let's do 3 again, and then Q. Oops. Yeah, all right, this broke because why did it break? Why did it break? Is it not okay, that was surprising. Read. Oh yeah, I mean, this is gonna be gnarly to debug, but yeah. Oh no. Yeah, this is gonna be a little nasty to actually get it working, but you can see like I had to enter 2 times.
Twice before it registered it, yeah.
Yeah, that's the only thing though. I mean, everything else is in place. I just need to do 2 times Q, because what's gonna happen is like re-inputs. I am calling it here, and again I'm calling it here.
You're reading inputs twice.
Yeah. So that's why yeah. As I said, like it's gonna be a little nasty, but yeah, let's actually go back to how it was. Let's write total to total like this, so that I can restore it later. And how much earlier was it? Maybe like 20 minutes. Yeah. This.
Nice. Is that Vim or Emacs?
It's Helix, but it's borrowed from Vim.
Oh, okay. The idea that you can jump back in your
Oh, wait.
project.
Later. Wait, what happened? Cat total.ml. I think I lost everything. Later 20 minutes. Okay, actually, okay, right. Total.ml. And earlier 20 minutes, I will write it to total.ml. Right, and then if I do cat total.ml, okay, this looks fine, and total. Okay, this has all right. So total.ml. This was what we had, and the only difference between the two now is right, Java this, and then OCaml this, and then I want them to be in sync. Oh, maybe like I just forgot. Let me just do that. Print string number, and then this, and now if I do Control C in both ends and I do this, now it should be pretty clear. Okay, 1, 2, A, B, S, D, A, B, C, 3, and Q. Yeah,
Oh, nice.
The only difference is like it doesn't print it. Like we already got this, but then yeah, there was some nasty difference there. But yeah, it's for some other time. But I just want you to take a final look at this, and let me also get rid of this, right? And let me do a side-by-side comparison of the some stream.java and this one. Right, so yeah, what do you think?
Much more concise.
Mm-hmm.
Yeah, it looks. So here's the thing: is I could definitely see once you understand what OCaml, like the whole functional paradigm, for sure. It's good. It's definitely like I like the where it starts with read and all that. It definitely reminds me of streams, and I don't have a lot of experience working with streams, but I do like them. It just seems like it's easier to whatever data structure. It's just easier to do whatever you want to that data structure or the elements inside that data structure. I like the way that looks. As far as like the syntax is just gonna take time, I think.
Yeah.
In terms of like getting used to. I'm
Mm-hmm.
looking at it, I'm trying to see like how readable is it? If line equals q, then none, else some line. I wouldn't say it's okay when it comes to readability. I
Mm-hmm.
wouldn't say it's anything special.
Mm-hmm.
It's like every other programming language, like in terms of like I don't it doesn't like read like super how do I put it? Yeah, I mean there's like if line equals q then none else some uh yeah, I guess in terms of readability it's fine, but I like it's very terse, it's very concise.
Yeah. Readability, at some point it is preferential. Uh, uh, you might argue that readability of this sequence, filter map, fold left. When you don't know those concepts, you just have no clue like what's happening. But once you understand them, the beauty of it is universal. You see, and I throw up this piece of information all the time, which is, once you understand it, it's not going to change. But there's a difference between looping and doing something like fold left, right? Because this loop is actually achieving what fold left is, but it's also doing so much more, right? And things like map. So we let's look at the map function again. Hello, Nakul. We're learning OCaml today. I'm at the end of the session, but I keep extending, and I'm getting so pretty tired here. Oh yeah, that's where we're at. But we're learning OCaml. Okay, so look at this function. Initially, when you look at it, there's no I mean you have no idea. You rather use a for loop, right? But once you get the
Hmm.
idea, it's not going to change in the sense that you understand that map, all it's going to do is apply your function to each of the elements, and then it gives you a new collection, right? It could be a sequence, could be a list, could be something else, right?
Hmm.
uh, that thing's not going to change. When you see a map, it's very clear what that thing is going to do. Unlike a for loop, how would you do this in a for loop? You would first, if you were to mimic this behavior, where you have a function that you can apply to each element of a collection, and what you want to do is like do it for every element in the collection and give back a new collection. If you were to do it manually inside Java, you would first initialize an empty collection, go through your existing collection, apply that function to each element, and keep adding the result into the collection, right? And at the end, you would have that initially empty collection to be filled with your new transformed values. Are you good?
Hmm.
Right?
Hmm.
But that's all. It's going to happen automatically, like it's going to return a collection. But inside that for loop, you're not going to do, nothing else is going to happen. Only transformations are going to happen. But
Hmm.
when you open the possibility of a for loop or a while loop, right? You can do
Hmm.
anything inside. Like it gives you power, but then it also opens up the possibility of having literally anything inside, and you have no idea. You have to go through the loop to understand what's happening. You see what I mean? And if
Yeah,
something
yeah,
awkward
I
is
do.
happening, I mean, a loop allows you to go awkwardly do anything, right? And there is power to it. But then look at the downside. Like if you have a loop, you're not really sure what's happening inside there unless you go and look at it. And that is a problem, right? Um, Not really a problem, but I'm just saying like it's a different way of doing things. Like you're more explicit there. You have complete control. Like when do you want to break the loop? When do you want to continue? Like all of those things are there, but then uh, they give you power, but they also can be very nasty. Like anybody can do anything inside a loop. You can go send an email inside a loop. I mean, of course, you can do like OCaml allows you to do it, but it's just limited in a way. Like when you and that's one of the reasons I was saying that it's going to be a nasty thing to do, because it's not that easy for me to just say, "Oh, don't do it twice," right?
Exactly. Yeah.
Uh, but the thing is, this is the more constraints you have, the nicer. I mean, I don't really know. It's just a different way of programming. You program with a lot of constraints in functional programming. Like if you remember the journey, it was more of what you have and what you want to get at, and what like how do you put these pieces together to actually get there, right? You were thinking less about how to actually do a loop, how do you collect things, right? You were doing more of how do I satisfy this type system, right?
Hmm.
And
Hmm.
that's a paradigm shift. And yeah, on the one side you have declarative. You declare that you want a box of integer. You declare that you want this sequence to be folded into an integer via this plus operator, right? You say that instead of saying, I'll have a variable, I'll have a loop, I'll update the variable inside the loop, and then at the end of the loop, I'll get that. You see the difference?
I'm starting to, yeah, yeah. I'm like, I definitely understand the idea of like the while loop being more open to, I mean, literally, you can, even visually, right? Like you
Mm-hmm.
can see the guts of the while loop. Whereas when I look
Mm-hmm.
at filter map, I don't, there's no guts to look at. It's just there.
Yeah,
Um,
yeah, yeah. And
so
it's
yeah, I, you know, really what it kind of comes down to is like use case. Like in your use case, you don't need to see the guts. So that's why it makes sense for you to just be like, look, I have one function. I have like one function that I want to apply to every element, and that's not going to change.
Hmm.
So in this case, it makes sense to like not, you don't need to go in and kind of like tweak around anything. So, but I guess you said also like it allows you to go in and tweak a bit more too if need be. So I guess it just kind of comes down to like use case if you know. But like I said, I definitely like the way that it looks in terms of it
Hmm.
reminds me of streams, and I definitely like the way streams look in Java.
Okay, so I can see the kind of questions you might have, right? It's not about the use case is simple. It's more about this system of programming will actually force you to breaking things down into smaller pieces, right? In this case, what you could do is like you write a function for this, and then you just call the function inside the loop, okay?
Yeah,
But
could do that. Yeah.
it's it just becomes more natural in the functional world where you I mean you're I mean a lot of the functions are just flying around expecting other functions to be passed in, right? So you're naturally forced to break your use case into smaller functions. So it's not just the fact that you can do only simple things in here. It's more about you can do complex things. Of course, you can do. Like it's a programming language. Whatever you can do in Java, you can in OCaml. And I would say that you can do more in OCaml because more in the sense, if you remember my digression about how I do not like the nulls, right? Uh,
Hmm.
you the kind of guarantees that you can make in OCaml is that it's like you must have heard of this phrase. If it compiles, it runs. You can't say the same thing about Java because at any point your system might be written in a way it returns to null and somebody has missed that check and it compiles, but no, it doesn't run. It crashes in some cases. That kind of a thing is almost impossible in a system like OCaml because there are these newer, I mean, better ideas of error handling, which makes it explicit. As you rightly recognized, it moved a runtime error into a compile time error, right? Those kinds of things are all over the place when you come to functional programming, right? Of course, it has exceptions, but that's not the usual way of handling errors, right? You have more gracious ways of handling errors, options, results, and whatnot, right? So you program in this system, and you should think in no way that it's less of a. I mean, you can do less with this. No, not at all. You can do anything, but with more constraints, more kind of a hand holding. But again, like there is you have to do some effort to make the compiler happy. It's always going to complain. Oh no, you cannot add an integer to a float. I cannot accept that. If you want to do it, you have to have a way of converting an integer to a float, or the other way around, right? And in some cases, you have to think, oh, is the float to int conversion always going to pass? If it doesn't pass, what is my program supposed to do? Because obviously you're going to run into such cases at runtime, but you have to put that logic in place. You are forced to put that logic in place so that at runtime it handles as you dictate it, right? It's not like in Java where you forget to handle an exception or checking null. It's going to let you run the program. It's going to crash at runtime. But in OCaml, no, it's not even going to let you compile the program. You have to tell me like what I need to do when something bad happens. You put that in place, and it runs, and it compiles, and it runs, and it probably never crashes. That's more the gist of it.
Hmm.
Yeah. All right. So I think that was it, and and that was the part. Like you don't really see a loop in this one. It's so linear, right? And it's very um, I mean, it's hidden. The fact that there is a loop here is hidden, and that's what I was. And that also should add up to the terseity. I mean, sorry, the terseness of the language, right?
Hmm.
You aren't really doing the loop yourself. The loop is going to happen underneath, but you just use the already built in abstractions, like, fold def is an abstraction that can loop over a sequence of things, right? But you don't really do that every time you want to loop over things. And how do you want to do it? And all of that, you get control, but you just supply the functions, right? That's what we did. We supplied a function to read input, we supplied a function to convert integers, and we supplied a function how to combine those integers, which is plus, right? That's
Hmm.
all. And then the program is in place. It is handling errors, it is printing stuff on screen, it is reading from input. Yeah, it's doing its job.
Hmm.
Yeah, and yeah, that's it. I really appreciate you spending the time. This was really good. I enjoyed this session. I enjoyed teaching OCaml to you, and yeah, I really appreciate the time.
Yeah, no worries, man. Likewise, it was a good session.
Okay, so we're good to end the session. I hope we can do more sessions like these. Let's see.
Yeah, just yeah, I'm always up for these, man. Just we can talk about it we can discuss it.
All
Whatever
right.
you're thinking, timings and all that stuff.
Yeah. All right, everyone who's in the chat. Have a good rest of the day. Bye.
All right, man. I'll see you. Take care. Bye.